I don't know if I managed to turn everything on like it should be, but I'm gonna wait up on and look at the stream myself when the delay is over. Let's see here. Yeah, seems to be working. Cool. Let's see, and we got a few people here. 7 people. All right. Some interesting stuff. Let's see here if there's. I'm just gonna check if there's any comments more on my post, and we're gonna get started pretty soon. And we are just loading in Unity as well, so I can get straight into it. Let's see here. There we go. All right, let's do this. So, Unity, here we go, and let's make this in the normal layout and not my dual screen layout. Better default. There we go. Everything seems to be working fine, and I hope everybody hears me that should be hearing me, or I don't know, that wants to hear me. I'm gonna move this over here. This is the first time I'm streaming, so I'm a little bit up in arms on how to do everything properly, but hopefully it will work out like it should. Okay, so I'm gonna make a game in Unity with the new tech stack, data-oriented tech stack, and hopefully we'll all learn something. And so I've been working with the Unity DOTS for about 1.5 years almost. I've started with a friend doing FPS type of game, and we've just been working on it constantly, and I feel like I've learned a lot, and I really do sympathize with a lot of people having trouble with DOTS, because it has changed a lot since they announced it and people started to work with it. But some parts of it I think are pretty stable, and we're gonna see what we can do, and everything is gonna be open source, and you can look at anything I do, and afterwards, and this is going to be obviously published, this live stream, so hopefully you can check it out later if you need it. Let's do like this. I've prepared, oh, that was the wrong two, these two. So I have, can you see them up there in the right corner, hopefully? Maybe I should just make it a little bit smaller, like that maybe. No, it just makes it harder to see actually. There we go. Maybe that's good enough. Like I said, I am new with this, so hopefully we'll make it happen. We're gonna start with player movement, which is most people, I guess, use like some sort of like the character controller in Unity or similar. There's a huge library of helpful stuff that Unity have made, or other people have made in traditional Unity. In DOTS, you can't really use the same thing. Most of the things you can't use at all, and we're gonna try to make it from scratch. I mean, it's not a lot of code, but it's still sort of from scratch, I guess. So I think we should just jump straight into it. I'm almost laughing about my own memeing here. Let's create a new folder and name it scripts, and let's create a new entry point. We need somewhere to start, because sometimes it's a bit tricky to like bootstrap and start up DOTS properly, so I think it's a good idea to just have like an entry point where this starts up first, and we can like continue from there. Entry point, yes, and I will probably misspell like half of the stuff I do, because that's just how I work apparently. Let's start Visual Studio here, and So, first of all, hopefully this is good enough resolution for people. I'm gonna check the stream myself. Yeah, that should be fine. So, entry point. So first of all, I just want to have like a... I'm gonna start the right project here. It apparently didn't start the generated project file. That's a little bit... All right. First of all, I'm gonna just go through a little bit of the game and what I've set up. Excuse me, I'm just I forgot to set the stage. So we're using Unity 2021 beta 7, and that's just because I've used it for like 3 or 4 weeks, so and it's been pretty stable so far. And also we are going to use the let's see here, latest version of all the DOTS related stuff, I think. So we have entities preview 7 at 0.11, and we have high definition rendering pipeline 9.0, and that's the big one where all the optimization comes together with hybrid render 0.51. And for those who doesn't know, so DOTS will encompass entities, job system, and burst. And I will go through those, what they mean, but that's what DOTS entails more or less. And then you have the hybrid render, which is like technically not DOTS. If I that's not the core functionality. It's more of a marriage between the rendering of the traditional Unity and DOTS. And it's not like it's gonna be like it's hybrid and it's temporary. It's the way they're gonna move forward. Like from right now at least. Maybe stuff will change, but right now they're gonna use the hybrid render is the way to go. So hybrid render basically takes DOTS based gameplay data and puts it through the HDRP rendering pipeline, and we're gonna use that. And we're also gonna use the Unity physics. That's like sort of instead of the physX that's built in with rigid bodies and stuff like that. This is their own situation. So there you have, that's the setup. And if we should take a quick peek at the design document, we can just run fairly fast. Well, I can explain this on top of without reading for you. That's boring. So we're gonna have like 4 or 5 different characters. Here we have a few. That's from the screenshot that I posted. Yeah, you can recognize that. This one is going to be our character that we can control, and these 2 are going to be 2 of the minions. And if we take a look at what they are, we can... Here we have more, so we can look at the shield. He's right there. We have the shield guy. And then we have the... That's the wrong... Yeah, that's right actually. Then we have the spawn. So this big dude is gonna spawn these small things, and this one has a laser, and his job is gonna be to shoot down this big dude, but he is vulnerable to the small spawns that the big dude is gonna spawn, right? So he gonna kill those, and he can't really do much about it. So we need to spawn these flamethrower dudes as well. So he's gonna kill these small guys, and then we have a shield guy as well, and that's because eventually he will like shoot big laser stuff against these guys, and our shield guys are gonna have to protect the laser guys. So that's sort of the rock, scissors, paper thing where stuff beats different stuff, and you need to like optimize your strategy and stuff. And then you're gonna have this guy, which you're gonna be able to control in a 3rd-person mode, and you're gonna be able to shoot laser, powerful laser, similar to this guy's laser, and powerful flamethrower. So that's the flamethrower, and then your own shield. So you're gonna be like a little bit of everything. and they're going to be able to help out wherever is needed. And then on top of this, so you're going to be able to switch between this guy in third person movement mode, something like this, right? Moving around like that. And a third person mode. I don't know how far we're going to go, but maybe something like this. And you're going to be able to control, hopefully, if the performance works out like I plan it, thousands of these small guys. So obviously we're not going to make this whole game today, but we're going to get a taste of everything and probably going to learn something if you haven't run with dots before. So let's get started. Like I said, we want an entry point. Actually, we can probably start with the character controller. So we can call it player controller, like that. And let's jump in here and see if we can get that to. There we go. So player controller. He needs to somehow collide with the ground, right? Let's make a duplicate out of this scene, and then main scene 01. Don't save, and then we're gonna get rid of everybody. But this, no, that was the wrong one. Commander. Like this, and we can put him like 0, 0, and let's push him all the way up. There we go. So we need the character controller on this guy. So if we add, first of all, we're gonna add something called physics shape. A physics shape is basically what you expect. What box collider and sphere colliders and all of those stuff are in traditional Unity, but these are more of like they call it authoring component, which means that it's like a setup component. They you specify how you want the shape or the properties of the object to be, and then it will convert into dots when you run. It will be a completely different form, and this mono behavior that we're looking at is going to be destroyed. And that's very critical, because mono behaviors are like, that it has nothing to do with dots. So if we make this convert, I don't meant for Unity conversion. Where's the convert thing? Convert to entity. It usually is a little bit of a tick somewhere here. You can a toggle, but maybe I haven't loaded in all of the stuff for that. Anyway, you can see it's created a normal collision box like this. We want a capsule. And I don't know, but that seems to be pretty fine for me. Oh, it's offsetted. That's not necessary. That's more like it. Maybe here. Now I'm being too detail focused. That should be enough. And then we need to add, so this is the equivalent of the capsule collider. And then we want a physics body. So this is the equivalent of a rigid body, right? It's not much weird going on here. So first of all, we want it to not rotate, and tumble over. That would be pretty stupid. What we could do is put in something called inertia tensor here, because if you recall in dots or in normal rigid body system, you have the lock XYZ rotation thing. That doesn't really exist here yet. I'm guessing they're gonna add it eventually, but we can do the same thing with inertia tensor. The original rigid body thing is actually inertia tensor thing where you lock the rotation. So these tensors values, they sort of have. Sorry, I just realized I had some chat going on. Does the checkbox for convert with dot editor package? Sorry for being a little bit off rail here, but somebody in the chat just pointed out that it's this thing. I remember dots editor. So that's a good thing. I just remember that, and good that you reminded me, because this will give us the little tick box in the inspector, so we can easily flip between converting an object to dots or keeping it as a game object. Some stuff we're gonna need to be keeping as a normal game object, because some stuff has no equivalent dots object yet. Maybe some parts will never get dots equivalents, very specific type of game objects, but most stuff probably will be converted eventually. And oh, by the way, I'm having a little bit of a sip of whiskey. So, and this was unfortunate that we have to look at this, but what inertial tensor is that we were looking at before is like how much energy does it take to get something rotating in a specific axis. So imagine you have like a cigar and you want to rotate it along the long axis. That would be pretty easy to get it spinning. That means it has a low inertial tensor in that axis. And if you were to rotate it end over end, that would be a pretty high inertial tensor. What we are looking at here, if this will kick in again, Commander, that's the same thing. So, but we want a good sort of reversed, because if we want it to not be able to rotate at all, it will basically mean to have an infinite inertial tensor on all axes. But infinity doesn't really present well in computer math, right? Not in most maths, I guess. So what we can do instead is treat the underlying value, which is purposely different, and it's inversed inertial tensor. So that means that it's this value 1 over this value. So if you would have a big inertial tensor, then you take 1 over that value, so 1 over 10,000 maybe, that it's a really low value, and then the other way around, it becomes a really high value. So it just flipped scale, so to speak, and that allows us to actually put in inverse inertial tensor to be 0, which will be like infinitely hard to rotate, locked, that is. But we need to do that in code, so let's do that in code first. So we're gonna add another component, and now you can see the convert to entity here. So this is this just adds this convert to entity thing, so Unity automatically gives you the ability to convert it easily. So let's pull in the play controller here. There we go. And hopefully, I don't know why it doesn't happen. There we go. For some reason it didn't kick in first. And then let's take a look at this object. When you want to work with Unity dots, you need to include the Unity entities framework. I'm just going to do like this, convert to entity. I'm going to explain what this is pretty soon, and then remove this, and then control dot, which like lets you find it pretty easily what namespace something belongs to. I'm sure a lot of you already know this. And then control dot again, and it will like, oh, you probably want to implement the interface that this one wants. Yes. So this thing will run when you start up Unity with the dots thing turned on an object, right? So all of the objects that has this turned on and an associated script with this thing implemented will convert to dots, and you can do your converting inside of this function. So we want to fix the inertial tensor. So we want to grab the other the actual information about the body and like fix the inertial tensor so it doesn't rotate. And so we need to get the body So if we do like this, unity physics dot body, rigid body, and then we do body dot, and then we have this manager, and this is I'm gonna call it for entity manager, even though it's for some reason auto corrected to dest, not auto corrected, but auto generated to dest manager. I don't know why they call it that, but it's the entity manager. It will be our portal into the DOTS universe, if you will, like literally actually. So we're gonna get the component on ourselves. The component will be our rigid body, which will contain a bunch of stuff here. It's similar to the rigid body normal Unity, but different in other ways. So we get here, we convert our commander stuff, and the commander will be the entity here, right? And now this is not fine with what I'm doing. Why is it not fine? Wait a minute, isn't this the... Oh, wait a minute, this is not the... I'm going for the wrong one. This should be collider, right? Because this is split in a few. I'm gonna actually pull up another project I have here to just so you don't have to wait for me to pull up code that I've already know how to write it. I just forgot about that. This is not actually the Unity dots object that we are interested in. I think it should be body. No, it's not body. Let's see here when this turns up. So this is our big project. First person movements. There we go. And here we does this does exactly somewhere here what we are trying to do. And I'm just physics mass. These are the two ones we need. Let's see here. Yeah, there we have it. Yeah, inertial, inverse inertial. There we go. This one we need. So we need to get the physics mass. My bad. So we go here and we pull out the physics mass. And I'm gonna use var almost everywhere because it's much easier. And on the right side, you're gonna see what type it is. I think it's an excellent thing with C# that they are like, oh, you don't want to put in the actual type because there's only one type coming out of that function. Then you can just put in variable. If everybody hates that, I might consider changing up for this stream, but I'm very comfortable with that, and I hope you guys are too, because I think it's a great feature. It just saves you a bunch of headache with or a bunch of writing time, and it makes the code more aligned so you can read it easily. So body, and we can actually do like this, body mass. Let's name it that instead. Physics mass, like this, and we're gonna import Unity mathematics as well. So now we have the inertial inverse inertial tensor, and this means like 0 here would mean infinity in these. So inertial tensor, and this is the inverse one. But I have 1 here in y-axis, which means it will be able to rotate along the y-axis, and that's just a bug in Unity physics. I'm planning on making a repository and showing it to them, but right now I'm just going to tell you that if you have 0, 0, 0, so it locks all of the axes, it won't apply friction as you expect to the body. So if you just put 1 here and then like manually set it to not rotate in the y-axis every frame, you like just set the y-axis to be 0 or like nothing every frame, then you will negate the possibility of rotating around y. So this should be enough, and we should actually be able to just press play on this and see it not fall down. It should just glide down, actually. I'm gonna... this is gonna obviously be available for everybody. Physics mass has not been... oh, maybe this is something to do with that it hasn't really the physics, the authoring component might not have gone so far, so it converted this physics body and physics shape to converted it and created it so we can get it here. That might be the problem actually. Let me just see if that makes a difference if we pull this player controller last in this chain. Hopefully it will make a difference. It did not. That's not good. Which is a bit embarrassing that I didn't anticipate this. We do this in a different way in our other project, so that's why I didn't anticipate this. If we disable, if we don't do this, we can have a look at the object. So this is how I would debug this. If we jump straight into to it and let it convert, and then take a look at the analysis entity debugger, and we pull that in, we will have the commander here. And you can see it has a physics mass right here. And you can see the so here are all the stuff converted, right? And we can look at all the components that these are DOTS components, right? You can't change this because they are like tied straightly into the DOTS framework, and they are so tightly packed and work in a specific way, so they haven't really figured out how to change this on the fly like you do with normal mono behaviors. And honestly, it's probably not going to be the same way in the future, because that's just like, it's not a performant way of doing this kind of thing. But I'm certain Unity is going to figure out a way for for people to actually manage this type of data a little bit more easily when you develop it. So we have a physics mass here. So the only reason it doesn't show up here is because it's not finished converting. So I'm going to just make a function that will run later, and it will convert it for me. And we will go into the further, because let's go into the next thing here. So we want a function that starts to, like an update function, and we want to like catch the first frame that this thing has a physics mass, and we want to like, oh, you have a physics mass, yeah, let's set your rotational thing so you don't move. That's our ambition. So let's create a class named system, player controller system, and let's inherit from system base. So system base, it's like the base class for doing almost any operation on stuff in DOTS. There is some other stuff that might be of interest to some people, but this is the easiest one by far. Unity has really done a good job of making this accessible. So if we take a look at this, it implements an update function, and inside this you can do whatever you want. So we want to do a loop on all objects that has a specific component on. So let's start also by making a component for our player, because remember, all this stuff that we have here to the right, that's going to be converted and into DOTS. And right now our player controller, it doesn't really do much converting, so it will literally nothing will happen from the player controller point of view. So we need to make it just add something so we can like find it later. It will make more sense when I structure the whole thing. So let's create a struct and call it player movement and state for now. And let's inherit from iComponent data. So this is the ground base object that all DOTS component will inherit from. And then we don't need anything right now inside of this. What we need to do is just take this entity manager and add component player movement state entity. So what we do now is that when this, let's see here if it loads, when this thing starts, it will run through the convert, and it will ask the entity manager to add the component player movement state to our entity. So, and this is not like a mono behavior. This thing that will be added to the entity is basically just a chunk of data that is associated with a specific entity. An entity is just an ID in this case. So it's just an ID that identifies along all other entities. And this entity will have a random, not a random, a component associated with it from now on. So if we then do like this, entities, so we have some sort of access to all our entities here, and we can make a for each loop. This is not a typical for each loop, and I will explain why. And we can do something like this. .run. So what this will do is this will convert into a function that will run on all entities that owns or has a player movement state associated with it. We will say own right now because our player, our commander, owns a player movement state right now. So it will trigger and run this. So right here we can do whatever we want. But right now I want to do the inertial tensor thing. So we can sort more stuff here. We can really filter this stuff and get exactly the setup of entities we want. So right now we want to do like this, and I'm going to explain to what this means. This means that we want entities that has player movement state but does not have physics mass. My bad. We actually want physics mass right now. So we want to, as soon as we have this on, you know, when we pressed play before, we had a situation where it just didn't like because the physics mass was not yet created. So we just want to pull it in and set it, right? And we actually can do like this instead, ref physics mass. And this does the same thing. The only difference is, physics mass like this. This does the same thing. The only difference is that we get to access the actual value of it as well. So now we can do something like this and get that working. And next frame. So next frame, when we have fixed our inertial tensor, we probably don't want to do it again. And just to make sure that I haven't screwed this up, we're gonna see if we can make this happen. So that's, I think, yeah, it falls through the floor probably. That's most likely it. So we're gonna just add a physics shape, and this is just like adding a mesh collider. The object has a non-readable mesh, whatever, doesn't matter. Friction, object will consider static, convert. Static is not something we will use in DOTS, and that might be it actually. Invalid operation. Oh, well, we saw that it actually fell down at least. Mesh that associated with ensure you have read write. Okay, we need to read write. But anyway, this guy falls down. That's why we don't see him. So we just need to make sure that the ground has collision. I didn't put it on the one. Yes, I did that. I wonder. Mountain. This should be it, shouldn't it? Let's see here. So we have this one, and it for some reason want me to put in read write, enable, apply, and then let's press play. There, now it looks better actually. Hopefully our guy stays on top of it. Yeah, that looks nice. So now you can see him there, and he doesn't fall down because he stands on top of stuff. And so now we can see him wobble. That's probably because he gets some sort of start rotation. So what we need to do, so what we want here is like make sure he's standing straight up, lock him, and then don't do it again. So straight up and lock him. So we're gonna need a few more components inside of here. Ref translation. So this is the same thing as the local position, essentially. Local position from a normal transform. Transform. And then rotation, and this is local rotation. So if we put this, position, we don't need to change position, I just remember. We just need to do like this, dot value, dot float, and I'm gonna explain more about this as soon as I'm done. That's supposed to be quaternion, right. So we get in here, we set the proper inertial tensor, and then we set it to be straight up. That's the point. And right now, actually, we could just make, I don't know if this is the right way to do it, but we can like make a small component tag, finish tag, that we put on this one when we're done. So let me show you. We don't want to go in here again, because once we've done this once, we don't need to do it again. That's sort of one of the things. So we can do with none finish tag, and if we add the finish tag to this one, then we won't go in here again, right? Because next time we go here, this entity that we did this on will have the finish tag, and it will not trigger this for each loop. So to add that, we have two different options. And now we're getting into the specifics of dots. So first of all, we can do like this: structural changes. Declare this whole system to be with structural changes, which means that we can do this entity manager dot add component finish, and then put in the entity. And we just need to do like this, entity, and now we get the actual entity ID in to work with if we want. If we don't need the actual ID, there's a lot of situation where you just need the component data, and you need to work on that. It doesn't matter where it belongs to. The calculation is self-contained into a few components. But if you need entity, you just add it the first thing in the for each loop, and then you put it here which thing you want to add a component to, and component, not component data. This will make it so the entity will get finish tag and not trigger a second loop. And we can do like this. I'm gonna do it like this instead. You debug.log added. Let's try that. So now we should get one added and then nothing more. And we get one added and then nothing more. And the guy stays perfectly still. Pretty good. So that's exactly what we want. So, and if we take a look in the entity debugger, we can see here that our commander has finish tag all the way down here, right? So now the next frame, we don't trigger it because we specify that this should not have any finish tag on it. Yeah, so we put the guy straight, and let's make the camera. That sounds like a good idea. All right, let me just explain this situation with the structural changes and add component. We should actually optimize it a little bit because it's a good practice to get learning with this. So with structural changes, the reason why we add that is because Unity has this big sort of database of the entities, and there's a ton of different systems like this one, all of the places that are going to work off of this database. And for those who hasn't worked with multi-threaded problems before, might not be so familiar with this, but when you have one set of data and you have a lot of system working against it, then you want to have some sort of thread safety. And one of the things that we can't do in this database whenever we want to, that's add or remove components. Because if we would have another thread running and doing stuff with the same entity, and then we removed a component straight into in the loop, this other system might just, where the hell did the component go, right? So what we do is that we can specify to Unity that we will probably make structural changes to the database inside of this for loop. So everything that this code touches, make sure that nobody else is working on it. That's more or less what this does. And in layman term, you could say like whenever you want to use entity manager inside of a function like this, or in a for each loop like this for component, you need to put it with structural changes. That's like, I don't think Unity actually will compile without this. Let's have a look. Yeah, there we go. I don't know if this is big enough. Entities for each lambda expression invokes get entity manager on blah blah blah, which is a reference type. This is not allowed with burst. Well, that's a different reason, but this is needed. That's it. If we do without burst, and I will explain what that is right after. Without burst, we will probably get the real message. We didn't, but I know it should be like this. Yeah. So the other way to do this, right, is to delay everything, to delay the modification of the database. So you can have a bunch of stuff. All of them are doing stuff with all of the components that they are working with, but they are like sort of recording all of their actions to some point in the future when everybody can like agree, okay, let's everybody pause and let's make database modifications, right? So what you can do is like you can record this component, add component thing into what's called an entity command buffer. I usually do like this, command buffer, entity command buffer. And then we need to declare which type of memory it should be, and I will jump into that after. And then instead of this, we do like this, add component entity. So this will be, this add component will be self-contained into an entity buffer, right? So now we can remove this. And afterwards we can do like this, command buffer playback entity manager, and then command buffer dispose. And let me explain what this means. So first of all, we record the modification here, and then we said like, okay, take this recorded modification history, or whatever you want to call it, modification buffer, and sort of replay it, playback it on top of this particular database. So now it does the transformation or the modification for us afterwards. So now you can have a bunch of different stuff recording all of the different component buffers while the database is completely unchanged, or more or less in this regard completely unchanged, and then afterwards, bam, everybody applies the same time. And then this thing with allocator is that this memory is not typical C# memory. It's sort of managed by Unity, and we need to dispose of it afterwards. And some might say, well, this is going backwards in time because, you know, we have C# for because garbage collection does the thing for us. We don't need to worry about it. Well, let's say it's not the most performant way of doing it, and Unity is trying to find some sort of a middle ground here where they can keep track of it for you if you in debug mode or stuff like that. But it will, if you just make everything work properly and dispose of your memory properly, and then let go of all the help wheels, all the help that Unity gives you, your code will run so fast. So that's sort of the reasoning behind it. All right, let's see here, just to make sure that I'm not smoking something, and this works like it should. Yeah, this guy is normal. We don't have any anything in the error or whatever. And if we take a look at the commander, we can see have a finish tag. So that works. So that's basically how you would do some modification to something once like this. You can juggle the tags to make it just do exactly what you need when you need it. So let's you know what, we can make a move. That sounds like a fun thing. Entity for each, and then let's have ref physics velocity like this, and then run. So what this means is, because dots are very, very subdivided into tiny components, so you only have what you need, the different parts that you would associate with a single rigid body in normal Unity, those different parts are really like put in different buckets in the system. And if you don't need one of them, it will just, Unity will not require you to create it. So if you're, I believe this, I don't know if this is the case, but imagine if you have a kinematic body that you like move explicitly every frame with something, then you probably don't need velocity, so you don't add that. And I think Unity physics will just like, oh, you don't have a physics velocity on your component, on your body. Well, then it's a kinematic more or less. So that's sort of how you would make the entity different. You would just add or remove a component, and often that component being with or being removed is like the actual like data that you don't need anymore. That's how the thing goes. So if we first of all do something like this, move, and then we pull in, I forget how you do this, so I'm gonna jump over to my other project just to put system. Not that it's hard, but I don't want to waste your time with this kind of stuff. That's mass delta, that's the wrong delta. Input, there we go. Well, I just did it pretty easily in this project. I could have written this from scratch. Anyway, float to move, or not, I said float, I wrote vector. That was a nice new like this. And after I've done like this, I often go back actually and make it variable, because it's like just so much easier to see, because everything becomes lined up. So if we do like this, it should be working. Oh, this, wait, we can actually make it a 3, so it's easier to fit it into the real 3-dimensional thing. So now we have some sort of movement thing here. So if we just take velocity dot linear, so you have both angular and linear, because you know it rotates and moves, right? And we just set this to move. Let's see what happens. I mean, obviously this is not playable in that sense, but probably gonna do something that we want to see. You know what? Yeah, let's do it like that. I'm gonna move this over. Yeah, so now we can move it. Obviously not much yet, but yeah, you see what I mean. So what we did here was that we prepared the movement input, and then we went into one of these for loops, and we like, oh, give me the physics velocity of every entity in the system, right? This will return all of them in the whole system. Right now we only have one, and that's the player. So we get the player and we just set its linear velocity to straight up where we pushed, which key we pressed. So that was pretty straightforward, I guess. If we introduce more physics object, we will not be able to get away with this because, or get away with it will not work, because you will control all of the dynamic bodies in the whole scene. So once again we turn to this filtering thing. So we filter on player movement state. Now we only get the entities which has the physics velocity, which is a dynamic rigid body, right? And is our and has our player component, which is only our player that we set up in the scene. So now we only control ourselves. And let's add some speed to this. So if we do like this, float, movement speed, we add that to this one. And now we need that value. So we need to move it over to an actual value that we can use. And I'm going to explain what that just meant right there. So in here, that means that we say to Unity, we are not going to change this value at all. And I think it will like warn you if you try to, not warn you, give errors if you try to change it and it's declared as in. Because that's like, this is data that we just want to read. And if you have 5 different systems which all run in parallel, this is super useful, because then you know, then Unity like, oh, none of these actually want to modify this data. So we can run all of them at the same time, because they just want the same data and they won't change it. So they won't get hung up on each other in any way. So we can take this and do movement speed. And feel free to ask anything in the chat if you have any questions. Maybe I should have said that like half an hour ago, but anyway. So yeah, now this will be 0, right? We can, just to show that this will be 0. If we move this poor guy now, I'm pressing WSD and nothing happens. So we need to set it. And we add this thing here, so we can set it there as well. So what I usually do is like this, add component data, and now it doesn't just expect the type, but expect the type actually declared with its variables. So you can see how it takes, let me just make it a little bit more clear. We want to add this, but we also want to add the actual value. Let me do like this, and yeah, maybe this is a little bit unclear. Let's do it like this. Player movement state new, like that, and then we do it like this. So that makes sense, right? We create our movement state and we add it to the component, to the entity. We add the component to the entity, the player movement state to the entity. And you can see how this is grayed out, can be simplified. So it removes it. That's because it can only be one thing, because that's the type that we're putting in. And I assume most of you have seen this feature in Visual Studio. And we don't want to have this fixed to 5, I don't think. So for once, it's something normal Unity. Public float movement speed. This variable is different from this one inside here, right? You need to treat it this completely different. One of them is in an object that will just live for a few frames while everything gets converted, and the other one is tightly packed inside of the DOTS core system. But if we go back here, now we will see that the commander has a movement speed. You can minimize this. Skalzam noted that you need to normalize the movement speed. Yeah, I already done that. And the normalize safe is because that's a version of that that will make sure if it's 0 that it just returns 0, so it doesn't give a mathematical error, because as you might know, you can't normalize a 0 vector. So it's already normalized. So, but a good thing. That's a good thing to. I should have explained that actually. So yes, so we have this thing here, right? That's the normal, plain normal Unity mono behavior. The only thing is that we just push it into a component and then get rid of the whole mono behavior. That's the thing. So if we have 5 there and press play, we will. For some reason it's lagging. No, there we go. Right. Sounds good. Looks good. Makes sense. Continue to ask stuff if it's something that's weird. So let's put the camera behind him, because the thing is right now that we don't really have a connection between the player and the camera. This is, I feel I'm gonna take some time for this, because this is one of the things that is confusing for people who start off. It was truly confusing for me, and like, not that I couldn't solve it, it was just like, I don't know really how to handle this, what this will entail for the general structure of my game and for my code. So how do you make this situation where you have two different, you have the dots and you have the old systems, and like the camera is still the normal camera that you're used to in Unity. So you need to convert the dots data, where you're supposed to be, what you're looking at, the third person camera position, and push that out to the normal Unity camera. So there's really a lot of ways to do this, but I have one way which I usually do, and is to bundle up my Unity dots entity, so the entity which like I decide over the camera, with the camera itself. So there's a trick to this, and I mean, it's not like a trick, a hidden thing. It's just that some people who work with dots have actually not used this, I believe, because I see people all the time ask about this. So remember this I component. This can be put on any entity, wherever you want, in any sense. Any entity in the system can own this, but it's a struct, so it means like it's packed in the memory perfectly well, and what you have there is what you have. There's nothing more. But if we create a class, that inherits the same thing or implements the same component data, this class will be like, it will still work sort of like exactly like a component. It just will not be able to be slid into the same fast optimized systems that the dots is built on. So class-based components should be kept to an absolute minimum. It's often really good to like transform your data and convert it to a point, and then in the very end push it out to maybe the camera or something else that is inside of a class component. So in this case, we just public camera player, and I don't know, camera. It sounds weird to name everything camera. I'm just gonna name this value because we're already inside a camera object. Yeah, so we need to move this, right? And what we can just start off with having this fixed behind the character. That sounds like a good idea to me, I think. So if we take this thing and move it underneath him, actually this might actually be easier than I thought. I just remember one thing. Let me just make sure this is nice and aligned. So we have a bunch of post-process effects. That looks pretty cool, actually. We're just gonna turn off most of it because we don't need to be all fancy with everything right now. So something like that, but I think we should move it a little bit like this, and then maybe turn it a little bit down. That looks fine. I'm gonna see what happens if I just let this convert, because remember now this camera component is underneath this commander. Let me just also, I'm gonna finish my sentence. It's the camera is underneath the commander, and the commander is the thing we convert, and the conversion is hierarchical or recursive. So we'll convert everything underneath. And when I started like a year ago with, or a lot more than a year ago actually, with this, if I remember correctly, the stuff underneath just disappeared, right? So if it wasn't something that was possible to convert, it just poof disappeared. Now I believe there's a bit of a difference, and like obviously it's moving faster sometimes than I have. It disappeared. How about that? So we should do something about that. So it just destroyed our camera, because it's like, oh, this is going to be a dots now. There's a camera there. That's not dots. We can't do that. We can't make that dots. So let's just destroy it. But we can add something else. We can add convert stop. Let's try that. I don't think our camera will move with us now, but let's just see. So now we have this convert, and it will convert all of these small things here, and then we'll come to the main camera, and it will see convert to entity stop. So we're like, no, don't try to convert it. Just leave it as a game object. And we press play on that one. Now it just, this is some sort of an exception from the Unity, from the HDRP system, which probably means that it's trying to do something, and this, what I'm doing right now with having the camera inside of the converting game object and all of the stuff, it's not really working with the early versions of HDRP, but you can see the point. The camera actually stayed in the scene, right? If you see here, first it's all right over here, and then when we convert, our commander is gone. He doesn't care. He's dots now. He doesn't show up in this view. But our camera, he's here, and he has nothing really changed about him. So, but let's do it like this instead. Let's pull him out, and let's go to the commander, and let's make us remember the camera now, and being able to handle him. So if we do public camera, camera like that, and then we add another one, and I'm going to do another type of adding this component thing that's does the exact same thing, but it's a little bit more slim, but I will leave the old one here so you can get a reference for how it can look. Add component data, entity, new, and then we want the player camera, and then we can just go straight to brackets and a semicolon. So this is the new object, right? This, and because it's specified type, the add component data already knows what it's supposed to add, so we don't need the template in between here. And now we can just say value, which is our camera, equals to camera. Sorry, like that. So now we have access to this. Now our camera in the world is associated with our player, and we can look at this. It's pretty easy to see. If we press play on this stuff, I think one more thing, we need to add the camera into this. So still, just to reiterate, this are just normal mono behavior stuff, and it shows up in the inspector like normally. And now if we press play here, and we take a look in the analysis of the entities, and we take a look at the commander, we will see him have all the stuff that we expect, including player movement state, and then all the way down here we have the finish tag and we have the player camera. And you can just double click main component camera here, and you will get to the actual camera in the scene which is referring to. So there you can actually see the connections when you're using this type of class component. Class I component data, right? This thing here. So we're gonna move this thing, and I'm gonna separate this in different systems. different for each loops, because it's cleaner that way. You could probably squeeze this together, might do that in the future, but right now let's just keep everything completely separated. And let's do another entities for each. And let's do a ref. No, I think we can actually do like this, and I'm going to explain why in just a bit. Player camera. Sorry. Slipped on my keyboard. Run. So now we have a situation which is very important that we address. So right now we're gonna have this error message which says entities for each, the one we just wrote, uses managed iComponent data. That refers to the class type component data. So we created this class. Class component data player camera, the one. This is only supporting when using without burst. So that means that we cannot do this because this is by default bursted. And burst I will continue to explain burst along the way, but burst, and my knowledge is a little bit, not super perfectly deep down low level, but I'm pretty sure I can explain to most people who are new to it what it does and why it's important. So the burst is basically, it's like, make sure that we have the memory aligned and tightly packed in a little box basically, and we put that over to the CPU and we say go, and we can ensure the CPU and the whole memory system that you will not need anything else than what I just gave you. Just do it as fast as you can. And because it won't have any access to it won't try to access any memory outside of this box, it will do it super fast, because memory access is what slows your computer down. That's the whole thing with Unity DOTS basically. Memory access, more or less. Data, the memory access oriented tech stack. Memory access oriented tech stack is almost like a synonym to DOTS. So we need to make this thing without burst. And this will make it run pretty much exactly like a normal C# code would do. Most of DOTS, the management systems behind it, are written in C#, I believe, and it was just not bother with compiling it to this specific burst box situation, and we'll just run it like a normal C# system. But then also, when we access this camera component inside of its value, that will be a memory access somewhere. We don't know where the camera data is, and we can't decide that because C# is not designed that way. So we will just jump somewhere, and that might take time. So without burst should always be used when you just need it. If you use without burst everywhere, there's no point on doing anything in DOTS actually. You need to burst as much as possible. Anyway, enough of that. So we want to push this around behind the player, and there we go. Something interesting happened there. So we need to, and we want to maybe record the offset, right? Ha! Our first crash shot. I don't know. I have a fairly quick computer, so we will be able to start it up pretty quickly. During seeing, I believe that will create a companion game object when the entity. Yeah, Fredrik Haraldsson here is actually an old colleague of mine where I worked before, and he's pointing out that there's a possibility to have a companion object system, and I've actually started dabbling with that in my own project. And let's just fix this and go to this one. Yeah, so the component create a companion game object when the entity is instantiated. Yeah, there is a way that I just haven't really gone into too deep, and I would actually really like to show you guys how it works, but the thing is I don't feel really enough comfortable with it because I believe there's a little bit trickiness with how it instantiate different systems. Sometimes when you have a reference to something, it that is like automatically generated with dots, it refers to like the game, the prefab in the project, and it tries to do stuff with it. That's, you know, it's the prefab, it's not the instantiation of it. So I would love to show that because I believe Fredrik is completely right here, that would be the better way of doing it. But the way I will do it is more or less the same, it's just that it's a little bit more manual. But then again, I believe that's a good thing for you, for people new to it, because then they will get a more foundational understanding what it means when they do stuff. Because this auto thing that he's referring to, I believe it's a little bit black box. I think the source code to it is open, but it's still like, you know, you need to read it to get it. So, and this way I'm going to do is just not that much harder, it's just a little bit more code. So, back to this situation here. We are looping all over everybody who have a player camera. And we don't need to filter this anymore, right? Because we already know that only our player has the player camera. So we wanna make this camera follow with the same sort of offset. So maybe we should just find the offset of this. We can store that here. I'm doing this a bit naively. I'm fully aware of that, but it's easier for people to understand if I don't try to optimize every single thing and make it super smart. So we're gonna have an offset, which is just like really the offset from this point to that point, or the other way around. So we can, you know, take the position of the character and offset our camera to that position every frame. So let's record that offset. So I just added the offset component here. Flow 3 is the same thing as vector 3. It's just that it's a new mathematical model library for them, and I think it's a good thing because then you separate it very clearly. So just treat this as a vector 3 offset, and let's do something like this. So we need to go to the camera transform dot position from this position. So remember, we're still in a normal mono behavior, and the position of everything is still valid and can be worked with. It's just that this transform, for example, this will disappear when we're done with the conversion. But right in the conversion here, in the convert function, we can access it just like we can access these variables. So now if we take this offset and we do something like this, player camera. Oh, I'm just realized we should actually rename this to camera, because now we have two variables in there, so we need to distinguish between them. Player camera dot position transform dot position equals 2, and now we need our own position, right? And that would be in local to world. Trans, I usually use that word because it's short for transform, and then position. So what we're doing here is that everything that is on the screen that is either drawn or is in a hierarchy will have local to world. So, and this is essentially transform dot position, dot rotation, and then dot scale, but it's all bundled up into one matrix, and it's easier than it sounds, like, for real. But this is like your end position when each frame. So we are going to put our camera at the same position as us. Well, not really. We need to offset this a little bit with the actual offset. Make sense? So we have our position. We offset us by the offset from when we press play, and we set the camera to that position every frame. This is probably not going to work exactly as we expect, or exactly as you expect, because we're going to have some rotational issues, but we'll fix that. I'm just going to show that it more or less works, hopefully. I haven't prepared this, I'm just trying, right? Yeah, so there you go. So you can see the camera is following. So that's a quite clear and easy way of how you communicate from DOTS out to the normal Unity systems. So now we should actually try to make this offset be in global space. So when you rotate with when you rotate the character, the camera stays behind you. And this should be basically just applying our own rotation to that offset. And you can do that from the local to world, but it's easier to pull in the rotation. And let me just do this, and I will explain exactly what it does afterwards. Value dot, that should be enough, I think. I might be wrong here, actually. It's harder than I thought to try to keep this straight in my head while I am talking in my stream. So if, oh, that did not seem to do much, actually. I want to let's pull in some stuff so we can rotate it, actually. We can make so we can rotate the player, right? That should be quite easy, actually. So, and I just want to rotate the camera around. No, I came from a first-person shooter where it's like not that thing. It's the similar relationship between the camera and the player. But correct me if I'm wrong, but it should be that you have the camera. When you rotate the camera, the player always like rotates and points the same way, right? So you rotate the camera and the player should point the same way as the camera. Sounds like I never played a third-person game, but it's, you know, your brain works in weird ways when you're streaming. So we want to rotate our camera when we rotate the mouse. So let's just pull in this mouse delta stuff here. We can do it in the beginning. So that mouse delta is something like a normal flow 2, so it's a vector 3, vector 2, I mean, weird. And we can rotate it at the same place where we move. So this could be our like movement, general movement of the character loop. So we want to grab the rotation here, and so you can see the difference here. Here we just gonna use the rotation to put up our camera in a specific place. Here we're actually gonna rotate our player with the mouse delta. So we can add something like camera Y rotation speed. Maybe that's reasonable. You know what? We don't need to see it from the perspective of the camera. We can make character rotation speed. Rotation speed X. No, Y again. Wrong one again. And let's push it inside here. And let's do it like this. So we just add this variable so it is with us in the player state. And let's make us, yeah, we already have that. So what we should do now is basically rotate our quaternion, that's a quaternion, around Y. And quaternion rotations, woohoo! Everybody loves that, doesn't they? Y rotation. So this is the rotation we will apply, and Y. They actually have a pretty good quick access thing here. So we create a quaternion which rotates around the y-axis with the amount we move the mouse left or right. So, right? And then we have this one here. So now we're probably going to do something like this. Value, that value refers to the quaternion. So we can do math.multiply y-rot times, oh, you know what? We don't really need to we don't really need to base it on the previous one, because we want to do like this. Public float, you're gonna get it, you're gonna understand what I mean here. Float y yaw, and then yaw, that's the right one, right? Yaw rotation. So let's just modify that one, and we don't need to set the first one, because we just gonna, this is gonna be a state. This is gonna be like which way you're aimed at. So you can do state dot y rotation, and then we just do like this. And now we can see the problem here, by the way, with in. We can't modify this one because we have in here. But we can just change this ref and it will, you know. So now we rotate jaw by how much we turn the mouse in the x-axis, left and right. We can actually multiply this by the state dot y rotation speed. It's rotation speed y, and now we have, so now we don't need to, we can just set the angle every frame, because we know we are already storing the actual absolute angle, the direction in this variable. So we can just do like this instead. Let me just, it's gonna make more sense when I'm done with this. Y rotation. This is basically it actually. Now we're gonna have some orientation problem here, and I'm realizing as I write this might not be the actual thing that you're interested in with the dots, because this is basically quaternion math. But I'm gonna try to make it as fast as possible and wrap it up, and you can look at it later on. So now when we're gonna need a rotation speed as well. I have no idea which scale this is in. Yeah. Oh, see, this is fun. So this is a little bit interesting to see how it rotates around us, but you know, don't follow us in that way. So this means that we are just I'm just going to make sure that I understand what we just had, what problem we just had here. Give me a second. Yeah, we're rotating around ourselves, and the camera, it's not rotating because it's not, the camera does not follow the character because it's underneath in the hierarchy. It's just following whatever point we are setting to it. Let's see here. I'm gonna have to drink a little bit. That was the wrong code actually. But we're rotating our character, so that works. So now we wanna aim the guy, the camera in the specific direction, right? And what we can do here is we can have. This is actually not my strong suit because I just made a few third-person games. I'm not too familiar with all of the different ways you can make this type of movement system, but I think we will do just fine with pitch. So we need a pitch, right? Well, that's for the camera actually. So we should have that over here. Let's see here. So we should. It's hard to think when you're live. It's a new experience for me. So we need to make sure the camera is aimed locally underneath the player offset, the player rotation. So whenever we move the player, the camera rotates with it and keeps the same rotation relative to the character's rotation. That's what we are looking for. So we could probably just set we can aim it. We can aim it at the player. That sounds like a good idea. Player. So we need to calculate where we're supposed to aim it, and we can do that in a fun way. We can do like this. Create a new object. This is a good thing to learn from for dots actually. So let's say we have a point here and we want to aim the camera at this point. It might be somewhere like here, a little bit to the right of the character and a little bit forward maybe. And the camera is supposed to be here and then aimed into that sight, right? And we can write code so it does this in the editor, but right now we don't care how it looks in the editor. We just want it to work in dots. Let's see here. We need a reference to this point, so we can use the dots transformation system for that. So we're gonna place this game object here, and it's gonna stay in this relative space towards the character, just like a normal thing. It's just that it's gonna be in dots. So we can do something like this. Player public. Let's have it here. Public entity focus point. And then now comes new stuff. But this is good. This is focus primary entity, and then we add public transform and focus point. Like that. So what just happened here is that a normal point in Unity will convert just fine if it doesn't have much on it. This doesn't have anything on it, it's just a point. And we can capture that point and it will be converted into dots and kept the same rotational or transformation point. That will be totally like you expect it to, but we can have a reference to it, just like you have a reference to transform in traditional Unity. But this way is we get the dots equivalent of this object. So when everything is up and running in dots, this entity we get back here will be the one that we should refer to access that point. And that's just an entity. So entity is just an index and a version, and it's basically just the index that matters. Well, the version exists matters as well, but the index is the thing that identifies more or less. And that's it. There's nothing more to it. But we have this now. We have access to it. So we can ask focus point position like this. Focus point position. Position maybe like that. And we can do something like that. Get component, and I will explain what this means. Local to world, and then we put in this thing. No, we have it in the play camera. Never mind. Focus point. So what this does is this is a little bit. This looks normal, but it's a little bit magic. This is basically a help system from Unity where they're like, it doesn't really matter how you're trying to use get component. We are going to make it do what you want it to do, but in the appropriate way. Because whether or not you have for example, the without burst or not, and whether you have some other modifying property on this loop, this get component will have to come from different places, sort of. And this is just their way of like, yeah, use this one and we'll figure out for you. So now we will get the local to world, which is the world transform of the object with position and rotation and everything. We'll get that point, that data that is associated with the focus point. So this point up in space here. And we get that position here. It returns a local to world, which has a quick way of accessing position. You can see here actually it has the right up forward position that you're used to, and rotation, which is quaternion in this case. But it's essentially a 4x4 matrix in the end. And that's the case in normal Unity as well. It's just that you don't really see it like that when you look at it. And now we have the position. So now we can see where we're supposed to aim it. So we can do like this, variable cam dir, maybe that's enough, direction, a little bit more. And we're gonna point it towards that, coming from the player position, the camera position, I mean, like that. This is the float 3, I assume, and this is the vector 3. So, and this, it's a little bit confused to what type we're actually after here. So let's just do like that. So we convert everything to Unity Dots, a new math system with the float 3. And now we have a direction for it. So now we can say something like this: player camera dot rotation, transform dot rotation, sorry, my bad, rotation is equal to quaternion look at, and this might be familiar for some of you. I'm going to use safe because I believe it takes care of normalization for me, and we're not that concerned with performance right here. The safe version of all of these will take a little bit more, a few more CPU cycles to figure out that we're not trying to do anything illegal, like normalizing a zero vector or trying to convert something into a quaternion that isn't a proper direction. So here we put in the camera direction because we have forward, and then we put up a normal float 3 0 1 0. So that's just up, right? Float 3 does not have the point dot forward, up, and right. You know, the vector 2 dot 3 dot up. That's the same thing. It's just this one is, you know, this is that thing in the background basically. But the new system doesn't have those quick accesses. This should be it. We should actually look straight onto this point right now. We just need to tie it in correctly. And there we go. So remember, this is the thing that we are converting, but we are getting out the entity it will be converted into, and we are then using that converted entity. Interesting word. Let's hope this works. That sort of works. It's just that we are walking in completely weird ways, but we are looking at the point, right? I think we should have a camera point as well. Look at how slow we are falling down. I don't really know why, actually. Probably something to do with damping. But we're looking at the right point. That's the important thing here. So we can do another, and I'm doing this like I said, in a least little bit more convoluted way, dots wise, but maybe easier for somebody who's not used to dots. So we can take a camera point, position maybe would be a better word, but I made my choice now, and we just make the same thing here. So we make another one of these things that we can access to see a specific point or a specific position in the world. And we can have a camera position, and we refer to the camera pointer instead. So this is the same thing we did before. We get the world coordinates of this point. Now we're just getting the camera position of this point. And so now we don't actually need this offset thing anymore. We can do it like that, and that should do the same thing, because now we have this actual proper point that we're going to create right now. So I'm going to do like this. I'm going to create an empty thing underneath here, camera position, and then I'm going to move it over here so it keeps the same global position relative to our guy here, and I'm going to hook it in here. It hasn't. I'm going to need to refresh that. So yeah, now it should be enough. There we go. Yeah, it's not like I expected anything else, but I don't know why it's falling so slow. That's a little bit weird to me. Otherwise, it's more or less like I expected it. We need to lower the Y rotation, maybe by 100 or something like that. So there we go. Right, and let's see if we can fix so it falls down properly. We'll have a look at what it's actually happening here. Physics body should probably be the one. Oh, we have probably screwed up this. We don't need to override the mass properties. And linear damping, blah blah blah, nothing special here. The shape probably has nothing special either. And we have a gravity factor which is 1. It should be correct, hopefully. It's strange why it doesn't fall down like it should be. Let me try this. Damping is normal. Velocity. Oh, a question. Frame rate independence. That's a good question, because this is one of those places where my love for dots sort of ends, because that's a strange thing. This is probably the problem we're having right now. Probably has nothing to do with frame rate. Obviously, we have a normal frame rate of 150 FPS. Nothing special about a clean project like this. But so frame rate independence in Unity, not Unity, DOTS, Unity physics. It is not frame rate independent right now. It doesn't really handle well speeding up or speeding down. I've seen a bunch of mention like this is something we're working on. It's still in preview. I've tried to implement my own frame rate independent, and you can do it in a specific way, but like doing it in a proper dots way doesn't really work. And I believe that it's because they are like is a little bit of magic going on for them behind the scenes, and they need to do it in a proper way relative to their own code and how they handle it. But you can basically disable the update function in dots in the physics system, and then manually call it in a normal mono behavior fixed update. So you like, oh, screw this normal update loop which runs as fast as possible. Let's take the functioning fixed update in a normal mono behavior and then make that update what we want to update. I've seen people do that. I've used that, but it's normally not that needed, because you can often like make your frame rate what you need it to be and continue working. And then you need to like sort of wait for Unity to fix it, I guess. But still, it's it's really annoying that this doesn't fall properly like it should do. I actually do not know why it doesn't do that. We need to also do this. I'm gonna explain why. So since we have this inertial tensor, we are not completely fixed in Y rotation because of a bug. So we have fixed X rotation, fixed Z rotation, but Y is just non-zero, and that's because there's a bug with this related to friction. Not friction like we have right now when we're falling slowly, just friction against other stuff. So because we have this allow it to rotate around the Y-axis, we need to reset the rotation of the system every frame. So I see right now that we have a situation where we're gonna have to move stuff apart, because right now we wanna rotate stuff around, because looking around, but we don't want to rotate the actual cylinder. I don't know if people have realized this, but most character controllers don't rotate the capsule collider which they use to collide with stuff, because if you were to stand, like if you stand along a wall, and this is your, maybe use something else, whatever, and this is your character, And what you do is you just use the mouse and you look around, so your character will rotate. Then you would, rotate along the wall you were standing next to. Like a so we don't want to rotate the actual physics object. We just want to rotate the camera and just make the gun or whatever rotate with us. So we should make something underneath here, and let's call it the rotation root, and let's put everything underneath that one. It cannot be. Okay, we need to just create a normal prefab here, player, and let's put this over here, original prefab, and then jump into that stuff, and then put everything except for a rotational root inside of that. So we're gonna rotate the rotational root, not the player collider. So we can do this by doing something. We should actually move most of this stuff up here. I'm gonna fix that. I'm gonna move stuff up here. It's gonna be pretty easy to fix everything. Remove offset and do like this. So now we have everything in this one instead. And let's convert this one so it uses the same thing, the same way of declaring it like this one, because it's a little bit easier for me to see. New, and maybe we can do something like this, a little bit of a editor trickery. Yes, and then we do like this, because we just moved over the variables, right? And we do like that. So now we have all those variables moved, and it doesn't matter for our mono behavior because that's not the same thing. And right down here, we are not longer accessing the player component, the player camera. So we need this thing instead. We can put it here in like that. And this just means that we moved it over to another component, and we need to pull in that component in this for each loop as well. So, and now we need to sort of separate the character from the other thing, from the rotation, the character collider from the rotation. So let's do it like this. Yeah, there we go. I think yes. I good point. This thing is setting. I just realized the chat has just pointed out the issue. The linear movement is we're falling slowly because we're setting it to whatever this says we're supposed to move. We're still supposed to move in XZ, right? But Y we need to just completely leave out of the situation. So I don't know. Let's just do something like this. Y velocity and Y, and then do the other way around afterwards. Thank you, Frederick. Like I said, it's trickier to stream than I realized. I know it's hard. I have huge respect for everybody who streams stuff like this. But yeah, your mind works a little bit slower. So this should make us fall quickly like normal. And then we should continue with making our rotation root. Rotation root. Let's call it that. That sounds good. And so like normal, we pull in basically a transform, and we're gonna manipulate that in dots wise instead of using what you would expect in normal Unity. So we're gonna rotate. So this thing right here, that's the player. That's the root object with the collider, right? And we're gonna set that so that it's straight and doesn't do anything every frame. But then we need to rotate the other one. So this thing which rotates when I turn my mouse, that should actually be applied to rotational roots. And we're gonna do that with a command buffer. And we're gonna create a new one. We already have the name, so we can just do like this. And we're gonna make sure we play it back here. We can actually play it back over here. Command buffer, and let's do like this. And I'm gonna explain why. And this is proper dots stuff. So hang in there. I will explain exactly why this is. Rotational root, and then a new rotation value y root. And let's just do like this. I'm gonna be sneaky and try it first, and then I'm going to explain. You can think about what I just did there for a few seconds. Rotational root, there we go. And let's just apply that stuff like that. Now we're getting somewhere. This looks actually pretty properly. I'm inventing a lot of new words here apparently. But now we have a situation where we can I'm walking underneath the zero plane, and the skybox is weirding out. It's something we'll just have to fix later. But I can turn around, and I still walk the same way. Like, it doesn't care if I turn around. So we need to rotate the vector which we're moving with, and that's really easy. That's actually one of the easier thing here. So so we have this velocity here, and we have this movement speed here, this move. So we can just do move equals to math dot multiply, and now we need actually get component, and you're gonna understand exactly what's happening here in a few moments. Rotation root, rotation view, rotation move, that should be it, and maybe this should be value. So let me explain what's happening here. This is also normal dot stuff. We have this thing get component again, so we're getting a component, and the component and the component we're getting is the rotation, and this is actually local rotation, but since our I think this will work. Since so we're getting the local rotation of all our rotational roots. Damn, a lot of R's here. So we're getting the rotation of this object, right? And this is the thing that's going to rotate when we rotate around for walking around. And because the player root, which is underneath that rotation never change, so we can just pull out the local rotation of this thing, and then take that rotation. So if we're turned like 90 degrees along this line, we get that 90 degrees rotation inside of this quaternion, and we apply that rotation to the move vector. So the move vector also rotate that 90 degrees. So we walk in the same direction we are looking at. That's really the issue here. So that should be enough. That should work. Let me see here. So we are rotating our character, and it doesn't work. I'm doing something weird here. Rotation. We should probably do this Y rotation first, actually, because let me just do like this. That's a little bit strange, actually. So we have this view rotation of that where we rotated at, and we just want to rotate the move input so it need move in the correct way. And you can oh right, this is a good learning opportunity. I'm gonna take my own failings as a learning opportunity for you guys. So we are rotating our character, right? And we are recording that in the command buffer, and that is going to be applied after the whole after this whole for each loop is done. So we're not going to get this new Y rotation from our input until the next frame when this is already when this is applied. So this is going to be the last frame's rotation, and it should still work. It's just that it's going to be one frame off, and that's basically just input delay in this case. So we can work with this. It's not a big deal, but I should try to fix it, and I don't really know why it doesn't really work like I should. Same type. We're doing something weird here. Let me see. Oh, yeah. Right. Another learning opportunity. So this for each loop, that's going over these components, and it's changing all of these components potentially. That means that if we try to access one of these, the type rotation from a completely different component, we might be changing the actual data. We might be changing in the same sort of we change the same data as we are actually iterating over. Remember I said like you want to like only modify the stuff you're actually on in the loop, and everything else you do through a command buffer. That means that you can only not read stuff in the same category as you're already reading. So this one, we can change this right here, right? This is valid. But if we try to do this, get component, this could be the same component as we are getting into our for loop. So we could be getting the same component that we are changing here, and that doesn't comply with how they are trying to do thread safety. We could do it by doing like this, moving it all the way to the right, and then change it to in, because now we are allowed to access this, because these two are in agreement that we're not going to change this. This is just a get, and this is also just a get, but then we're not allowed to do this. So let's do this. And I'm doing this, like I said, a little bit naively, and it's actually a lot, because I think it should be okay to be really naive and do it really like half-hazardly. And I'm not trying to be overly critical of anybody else's code or anything like that. It's just that I do this all the time myself, just like trying to get it to work. And this will like explain the problem, and we'll solve it in a very obvious way, but maybe not the most optimal or the most correct way of doing it. So what we do, we just make this in two different stages. That's really it. We do like this. This will all be done, and we will have set the rotation of this stuff to 0, so our play collider does not rotate or doesn't do anything like that. Everything will be done when we get to this part. So we can just not use this rotation anymore. And now we are fine to access this view rotation. This actually looks like it works. And I'm seeing some input here from Scalzam. In regular Unity, I would inverse transform direction from the rotational root. Yeah, right now, like, my mind is a little bit scrambled. I feel like it's, like I said, it's tricky there to think about this stuff. But yeah, the inverse root. If you could, because I don't really know when you wrote this and what this related to, but if you could explain it once more, maybe I can implement it, because maybe I've just missed an obvious way of hooking this rotation up. Because we can just take the local to world transform of our rotational root and then inverse that with the Unity DOTS math library and apply it to something. But I'm not really sure which one you're meaning, which one you're sort of pointing to right now. And this should be right here. So yeah. Let's move on. Now we have some sort of a situation here where we can run around, and it obviously looks very, very bare bone and stuff, but we're not trying to make a super good looking and cool game in a few hours here. And I'm not trying to make this whole game in this session. Everything will be available later, obviously, so you can watch it in your own time. And I'm going to stream a bunch of more. Even if nobody cares, because I think it's fun and it's nice to document this stuff. So people can like find specific time points if there's something I explained sometime. So yeah, let's continue. We have so we can walk around. Let's go over to RTS camera mode. So we're gonna take it from here up here, so we can look down, because remember this is an RTS hybrid thing. So let's introduce a new enum. So public enum camera mode, maybe a little bit of a generalized name there, but whatever. Third person overview. That should be enough. And then we do like this. Let's put an S on that one, so we can have different names on here, like that. And it's only 2 states, so it could be a boolean, but I don't want to make stuff that is like, it's not actually an on-off thing, right? It could be thought of an on-off, like overview on or off, but it's just 2 different modes, so I prefer to have enum even if it's only 2 states. And let's do it like this. So these 2 things, if state dot camera mode equals third person. Let's do that for both of these. And that should more or less be it. And let's say we press tab to jump over to the other. So let's do something like this. Var switch camera input dot get. I'm gonna take a look at your comment in a second. Tab. So yeah, let's see here. The move vector is basically direction you want to move in local space of the rotation. So by transforming the world. Oh yes, yes, that's completely correct. God damn it. But I'm basically doing the same thing. I think what you're talking about is actually like the same thing as what I'm doing. We still need to pull out some sort of rotational data from this rotation entity, from this root, right? And we still need to apply it. And I could pull out the inverse to world or something like that. Wouldn't it be the local to world instead of world to local? Maybe I'm wrong here. Inverse transform direction should be direction times inverse, yeah, something like that. But anyway, this thing does, I think, and please correct me if I'm wrong, but I think it basically does the same thing.
and it's enough for us anyway. But good point. I appreciate that very much, that you came with that input. So let's do the switch between another camera, shall we? If there, so we should switch over this mode. If it will be a bit verbose this, but I think it's a good thing. Could you please make the, yes, of course I could make the text bigger, maybe like that. Good thing you're pointing out, continue pointing out stuff that bothers you, and if I can enlarge it even more if somebody wants. Wrong one. That should be it, right? I could make a switch case, but it's like way more code because, you know, the setup. So we are switching between them. So that means that basically right now we've pressed tab. It all should just deactivate our current input. Let's just test that. So we start off like this and we can move and then press tab and we can't move anything anymore, and then press tab again and we can move. So yeah, it's pretty straightforward. Looking for this key down thing, and I'm not using the new input system on purpose because I don't want to have everything to be a new variable thing that I don't really know. I mean, I'm new to all of this stuff as well. Well, at least I have a 1 year experience, but with the input system, I'm not going to bother with that yet. So we detect the key down on that, and we switch between third person and overview. And when we're in third person, we execute this movement system that we just built. And when we're not in that, we are not executing them. Right now, we're not doing not much of anything. So let's do that. And we're gonna separate this once again because I believe that's the more easier way to understand. So let's take first in the camera. We're gonna introduce more components as we need them. Right now we only want the camera, and we need both without burst and run on that one. Because, you know, as I explained earlier, the reference to our camera is a reference type. It's not allowed at all in burst. So if you are going to access your camera, you need to do it outside of burst. So let's do it like this. State dot oh, we need one more straight away. My bad. Let's do this like this and overview. Could you do this by removing the current camera controlling and adding the different one? Yeah, I could. Yes. This is nice. I like this. I haven't really thought about it that way. Maybe we should do that because, I mean, there's a lot of stuff that I do in our bigger project where removing and adding components like frame by frame basis really makes a lot of sense. But like switching between different systems, I haven't really done. But I kind of like that. Let's do that instead. Let's erase this. This is old thinking. Thank you. And this will like show off the situation pretty well, I think. So it's gonna be obvious how I do it when I come to that. I just need to clean up. This should be the same. So this switch instead should be player movement state. You know what? I just realized there's one problem with this, and that's like the whole state will obviously be reset as soon as you are going into the camera, and then when you go back, your orientation and stuff that we explicitly save in this state will be gone. So we can't really do it with this stuff, but we could do it somehow. with components if we want to, and why not? Why not try that? That sounds like a reasonable way of doing it. And this is subjective. I don't really know which way would be the best, but it's certainly a possible and a fairly good way, in my opinion, to do it. So we could do something like this. First, third person mode, and we just make that a tag for now, which means like an empty component, and then we go to overview mode. Like I said, the only reason I could be using this one and just remove that from the component, but we have a bunch of stuff inside here that we want to save. But we might be introducing more other states into these components in the future, which we need for the appropriate movements mode. But right now it just needs to be tags. So what we do right now is that we take all here. Oh, sorry. So we only execute this update function when we are doing when we have this third person mode on our component, and then this thing only becomes like one line, and not even like that. I'm gonna explain in a few seconds. So we are in third person mode because we own one of these tags, and we need to switch over. So we need to take the component command buffer and remove this one, and we need to have the entity like that, and then we need to add the overview mode, add component. So we just switch them over, and then we add this one right here. No, sorry, my bad. Right here, that's better. So both of these are just going to be played when we have a third person mode component on our entity. And then we can do something like this. Let's sorry, overview mode, third person mode. I don't know if that's the best way to name it, but that'll do for now. entity, and now we just switch through these basically. Overview mode. So this one will only run when we're in complete overview mode, and we should be able to test. We need to add the third person mode, so we start with one of them, obviously. Can remove that, it's not needed anymore. This manager, so this is just on the start. We add component entity like that, so we start with that component on. Reload that, press play. My throat is getting really dry. And yeah, that sounds good. And we can inspect this now. This is, I like this. I can show stuff that is relevant. Player has a third person mode, and then we press tab, bam, switched over to a overview mode. And we maybe got a entity has not been initialized. That's interesting. Entity command buffer not been initialized. That's probably something to do with that I'm using the same command buffer 2 times here. Maybe. Let's do it like this, just to make it easier. To make sure that's not the problem. What? Oh, what keyboard I'm using? I'm actually not using a. I hope my mic is not picking up and like making a crazy about my I'm one of those weird guys. I've had a bunch of problem with my wrist, so this is actually like necessary for me. If I don't use one of these keyboards, my this thing wrist will like die on me basically. It's really annoying. Oh, now you know what? Let's just not have 2 different command buffers. I'm just being stupid. Apparently, this add is done before after we have already used this stuff. So obviously this should be after. We should always, you know, play back and dispose of it the very last thing, right? Yeah, that should be it. So right now, when we're in here, and we can do something like this also, return right here, and that will make sense when I explain it. Like, so when we press switch camera, we want to like switch it right away and return. This way we will actually have one frame where we won't have either, because you know this is important stuff when we're working with dots. I'm going to explain my thoughts here. We will get in here in a frame, we will press the tab button, it will trigger, it will record the remove and add into this buffer, and then it will return out of this loop, this current one loop. If we would have 2 or 3 entities, this will only return out of one of the entities execution, but this will return out of this, and since we only have one, this will like end this execution. But we will not have the overview component on our entity yet, because that happens here when we are playing back this add. Playback, like, you know, applying it basically. So we can actually just do like this. You know what, we can just remove the return. It doesn't really do much difference. Now it will execute this code once, even though you already pressed the button, and then it will switch, and it, you know, it doesn't matter. It's not even bad coding practice. I think it's just like, it doesn't really matter. It's just something to think about. All right, let's do the camera up in the air. So we have one thing here, continuing with the dots introduction stuff. Right now we want to move the camera, right? We want to set the camera above like an RTS game, but the problem is we need to do that by raycasting and knowing where we are sort of along the ground, so we can handle different terrain in the future if we want to. And it's good practice to try that out. And that code, that raycast, that's something that we really want to burst. We want to be able to put that in that little optimized box and give it to the burst system or the CPU, and it just finds the ground and do everything for us really quickly. It's not necessary right now, but that's the way it should be done. And when we are manipulating this player camera, this camera, Unity camera, we can't burst because that's a reference type, that's a mono behavior basically, or a component. Unity component, normal. So we need to like space this out, and that's one of the things that's very important with dots to realize, that you need to put it in, you need to like do everything in order, and every part of it you need to do in the fast way. So we should calculate wherever we want our camera to be, and then after we are we're done with that, we should go into a new one of these entities for each thing and apply it to the camera. So let's create another one. We just make a copy, not bad, like that. And let's, should be the same, only we remove that one. And we can handle the input detection right there. This should basically only be applying the final position. Yeah, that should be it. So right here we can do, and now we need to raycast. So the way you raycast in with Unity dots with Unity physics is that you need a reference to the physics data. It's not a static access and you just like straight into physics like the normal old version where you can just take physics whatever you want in whatever part of the code. You can do that, but it's a little bit more, you need to do it in a other structured way. So we need a private variable called collision world. We can name that collision world, and I use this annotation for variables that is members of the class. And then we need to override something called onCreate, and I'm going to explain this as soon as I've written the code. Get component, get or create component, and now we have physics world, I think is the actual thing we're looking for. You know what? I'm gonna have to take a look in my other code. I'm just a little bit first person movement system. It's a lot of namespaces to keep track of sometimes. There we go. So you need this one. Actually, my bad. So this is a system. Get or create like that. This is a system. This is similar to the system we are currently in. So this is the system that builds the physics world. So it like just builds a whole like current frame, up-to-date version of exactly where everything is and their associated physics values, more or less collision values, I think. So we need to take this data and we need to put it into our for each loop and say like, oh, rate cost. So the way we do that is we do something like this. Let me show you. Here we are, collision world, and we do physics world, collision world. So exactly what this means and where it's heading or wherever, it's not really super important. The thing you need to know is that this is our reference to the other system, just like our own system. And there is something inside of the physics world object here called collision world, which is the collision, all the collision data like bundled up. And then we can do something like this, read only. And now we declare to Unity that we are only going to read from this. Array cost is just a read. It obviously doesn't change the collision. So we just want to find the ground, right? And that's just a straight up read, where's the ground with array cost. So we can do something like this. Collision world, array cost, and then it takes an input. And right now we're actually going to need to take away the unit engine because they're going to collide. So I'm just going to move over everything to use explicit. Well, I think it's possible to do without but this is cleaner, so you know which part is Unity new and Unity old, so to speak. And that should be it. And now we have the rate cost input, and this is normal rate cost stuff. And I think we should like start maybe 500 meters up or something, and we can just put in start height 500, something like that. It's not a big deal where we start, and then we can just rate costs 500 minus down. So or start new float 3, and then we do for now 0 height 0, and then we have end, which should be the negative version. So we have start and we have end and we have filter, and right now we can there is this is the filter, not layers from Unity, traditional Unity, but not the exact same, but it's the same principle. So we need to have the filter for which is the ground, and that would be something like this: public collision filter and ground filter. We can name filter, And there is a way to do this pretty easily. I might be physics category tags. There we go. Ground tags. I think this is the one. I'm gonna give it a little more explanation soon. Ground filter dot value. Oh, collides with should be the collide. I don't know why it doesn't give me the autocorrect. That's a little bit weird sometimes with this. That's strange. That's really what? Now I'm confused actually. So that's a collision filter. That's the normal collision filter. Why is that not giving me lights with? That should be totally perfectly fine. What's going on? Invalid initialization. Invalid. I am very confused right now. I don't know what's going on here. We are just okay. Let's do like that. Let's try this instead. Ground filter collision filter dot default. Oh yes. Yes. Thanks, chat. Wow. I almost said I'm embarrassed, but I just gonna complain, blame my streamer brain that obviously it's not working like it should be. This is just because you can't set a value inside of a struct. You need to set the whole struct. I almost said everybody knows this, but that would be a little bit elitist of me. That's not really what I meant. Strange. Sometimes your brain just blocks out the very obvious thing. Oh, Miss Yeti, hi. Welcome to the stream. Feel free to ask anything. So now we have, this is basically like layer mask. You know how you put in which layer you want to collide with in a normal Unity. This is the same thing, but it's DOTS version, Unity physics version. And then we convert it because this only like takes one filter. This filter contains two. Let me just get rid of that. Takes two things. It takes both which one it collides with and which one it belongs to. And in the case of raycast, I don't think belongs to matters. I might be wrong on that, and we might figure that out later. But I don't believe that matters right now. So right now we're gonna use that new thing we just made here. Collision filter. Ground filter, I mean. So that's the one, and that's the thing that is put into the raycast. And now we can see if we collide with something. And we can do like this, because this is a nice learning opportunity again. Unity engine, and for now on I'm gonna do like this with Unity engine because I've excluded that namespace out of this file. This, only returns a boolean if we hit or not. We need the actual position, right? So there's an overloaded version of this which has an out var raycast hit, and I'm using variable like this right in the function call because it's so much easier than declaring it in first. And by using var, it's just like, yeah, whatever you want it to be to come out. I know there's a position in there, so that's the only thing I'm looking for. Position. I'm kind of new to coding. Oh, you're kind of new to coding. You're very welcome to stay and look at this. But if you're new to coding, don't be discouraged by this stream and this coding structure or framework, because DOTS is, first of all, I would argue is a little bit, it will be a bit harder than normal Unity, I think, especially to at least to use it properly. But right now it's in preview mode, so it's much harder to use it if you need to experiment a lot. So if you're new to coding and try DOTS for the first time, it might be not the greatest idea. The rest of the chat can fill in if you agree or disagree with me, but you're very welcome to stay, and I will explain everything as best as I could, but it could be a little bit trickier if you don't have any programming experience. Anyway, now we're gonna see this position pop out. Let's load that stuff in, and let's press play on that one. So first of all, nothing's gonna happen, right? Because we are not in the overview mode yet. So you can walk around with this fella here, and then we press tab. And apparently this doesn't work, so shame on me. I haven't set the collision filter, so we have nothing to collide with yet. First of all, I'm going to create a collision. So this is the way you do it. Physics material is that. No, that's the old one. There's a way to do it. Maybe we can do it straight in this thing. We need to take the ground and its collider, which is this thing, physics shape mesh collider. We need to have the collision filter belongs to, and we need, right now there's just a number, undefined physics category, number 1 or number 0. We need to have names on them so we can distinguish between them a little bit better. So I'm just gonna be looking for this damn there, physics category names. There we have. It's a good name. And let's name player and ground. That should be enough for now. So now they show up here, so we can take the player belongs to only player, but cool. I hate these long drop down menus, but so it belongs to player but collides with ground, and then the ground in turn Scalzam, thank you. I might have needed your comment right there about if I didn't realize it myself. So the ground need to be in the ground thing and collide with everything. I guess doesn't really matter. I don't envision much to fall through the ground right now. So that should probably be it. No, it's not it. I need to set it on the player as well. So the player's raycast that we just defined actually collides with just the ground. Now we're set. Alright, we're up and running, and tab. And apparently we're not doing it. I'm gonna try something. This should not matter really, but probably is the reason why it's weird. So belongs to, I'm just gonna set that so it belongs to everything. I've had problems with this. This shouldn't matter, but it does for some reason. Let me just do like this, and then I'm gonna do like this. Default belongs to, because this is a static property of the collision filter, which says collide with everything. So this in turn, we just pick out the belongs to part of it, which says belongs to everything, and then we put this into belong, and we'll see if that works. If that doesn't work, that would be one of those annoying thing that we need to research live, which I hope to keep to a minimum, or not minimum, but not waste your time too much. There we go. So now we get some sort of a collision here. This is the collision with the ground at 0, 0. So I don't really know where it is, but somewhere around here. So now we want to put our camera on top of that. And So we have two things to do here. We need to put the camera on top of that so it looks down, and we need to make sure that we start wherever our character is, because we don't want to start at 0, 0. So when we switch over, we want to sort of hand over the position to the camera system. So we can, now we can actually use something here. Put it in our component. So float 3, camera ground position. So right when we switch over, so right here, we should add the ground position with some data. So we have an overload version of this, which takes this, and we can set the value we added to this component. It's not longer a component tag, I guess. It's a normal component, and then we can push in some positional data. So now we need the local to world, right? Trans, and for the I just abbreviate transform. It sounds weird sometimes. And then we say position, and that's going to be on the ground, right? And we're not interested in the y value, but this is going to be perfect place XZ on the map to start our journey for the overview. So right here, instead of using 0, 0, we should do something like this. We should take the overview. So right now, the overview, we need data inside of it, so we can't really have it like just a filter. We need to push it into the system so we can do stuff with it. View overview, and then we might do something like this: ground position, and then plus height. You know what? Let's not do it exactly like that. Let's just do it like this instead. So we take the y and we put that at height like that, and then we take this might be the same issue as we had before. Am I imagining things here? Wow, it's interesting how my brain is like, nope, not this time, not on stream. I'm gonna be cautious and do it like this instead. Height. So we are basically just transferring in the height value into each of these. So either one of them is 500 units up, and the other one is 500 units down. And now we should just get our hit exactly where we switched over from our character. And the intent is to be able to switch over, and maybe we don't even want to take it from the character position. I don't really know. But switch over, and then the player is going to be static, and we're just going to move around with the RTS camera. So now is an interesting thing here, because this without burst right now, that's actually doing us a weird favor right now, and it's like basically allowing this to happen. And if we remove that, we're still going to be able to have it happen. And this is like, if you are new to DOTS, this is important. When we compile this, I don't know if it's going to be in runtime or no. This is one of those runtime errors. So if we press play here, we're going to get an error when we try to switch over. We even get an error right now. So we get unsupported string format method called. That is referring to the plus right now, because the plus is the string formatting system. If we just were to write out this, it would be the same thing. It doesn't matter. We can just do that right now. But the thing is that a string is very much of managed type. It's not a reference type. It's not a value type like float is. So DOTS will not take care of it. It will not burst this code. There is some I think they're working on some sort of log system for that works inside of DOTS, and maybe they have that in some sort of preview. But the point is that when we compile this and run, it will work. And you see here, it's the same message actually. When we compile this and run, it works, and we can press tab and we see the output. But the thing is that this method is no longer bursted. And if you try to build this, when you build a DOTS project, if you have something like strings inside of bursted code, the build process would just like, no, you cannot do this, because we want everything to be explicitly burst or not burst. We will not like force this to be non-burst for you just because you forgot a string inside. But it's good to have this, just not on the screen when you don't need it. Now we will not get that issue, because it would basically just work like normal, and this code will be faster. Now there's not much happening here, so not much to make it go faster, but when we press tab, we don't get the log, but we don't either get the error message about the burst thing. So let's move on. Let's take this position and let's see if we can move it around. Let's put the camera position inside of here, because remember, we have this final thing here, burst without burst, where we're gonna apply the camera position since the camera is not burstable. But here, right here, we can calculate the whole shebang about where exactly the camera is supposed to be, with it burst and with it being fast. So let's do like this. I have an idea. Let's start this thing, camera position, at the this is a little bit hacky, but you understand. This is the thing that takes time and does only add a little bit of production quality to it, so we're gonna skip this. So I'm just gonna take this and pull it 500 units above the player, so we have the player position here, and then I just push the camera straight up. But that's just the first frame when we switch over to the RTS camera. And then we will take the camera system, because I don't want to have like a weird frame where if it doesn't, well, actually, maybe. I think you get what I mean here. That frame should have some sort of camera position. But we're not going to be in overview mode right here, because the overview mode is going to be applied the next frame. So overview, so we could actually recalculate the camera position pretty easily, I think. Yeah, you know what? We don't need that. We don't need to set it. We can just do like this. We can just take the overview dot camera position equals to raycast hit dot position plus our height, right? So plus something like this, height. So now we're gonna just interesting sound, go straight up in there and be there, and we can push in some movement at the same time actually, and make sure our camera is pointing in the right direction. So let's add well, I mean, we're just gonna basically look straight down statically, so we don't really need to calculate any rotation. It's a set thing. So we have the camera position, and we can now apply it. So we can just take, now we're in non-bursted code, and we can take the transform position and we can push in this thing here. We don't need this one probably, so we can do it like this. So we just want to read overviews data, right? So we can use an in here, and we don't need the entity probably, so we can just move that away, and the camera position, and then let's just do it so like the camera translation dot rotation is quaternion dot look at, and this is going to be straight down. So we're going to look straight down, new float 3, 0, -1, 0, and then forward might be something like float 3, 0, 0, 1. So that means, let me see if I have something to I'm going to use this one. Making sure my wrist is not totally broken. So imagine this being like the camera looking straight forward. So we're going to look straight forward with its local up vector pointing straight in the z-axis. That's our RTS camera, 500 meters up. I get that for some of you this is pretty straightforward, but I want to be sure that everybody is on the same deal here. So this might actually be most of the code to make it move like that. And it would just flip in one frame. And we can do a transition if people want, if I want, I guess. Duplicate. Oh, right. I'm going to show you. This is a good thing. So you saw this issue. Entity query contains a filter with duplicate. I don't know if you can see that. I'm going to read it. Entity query contains a filter with a duplicated component type overview mode. That means that this is referred to as a query, sort of. And the query contains the same thing as we're accessing here. And if it's inside of this parameters that we want to use, we don't need to filter it anymore, or at least we should not filter it anymore. So this will do the filtering for us. So that's what it's complaining, and that's like the specific this stuff that's gonna throw you off the first month or so, or week maybe, that you're programming in DOTS. So I'm making sure that you understand these pitfalls. The error is sort of alright, but it's not super clear if you've never seen it before. So we walk around and then we press tab, and bam, we're in overview mode. So, and we're really far up, so that might be a little bit too far up, I guess. Let's fix that. So let's do something like this. Play a movement state. We can add this offset right here. We can do something like this. RTS camera height, right? And then we add this stuff right here, and then we just put it in. And I know I'm going fast, but this is basically just adding another variable into the system that we can access in our own loops. And now we can take away the height here because we already have a height, and we see all the errors here. And then we can do like this, height, RTS camera height, and let's just use that negative like that. So now that 500 value, which put us very far up, is something that we can set manually. So we should maybe set it to, I don't know, 200. I want a good overview because we're gonna control a lot of units in the end when this comes to it. So now we move around and we press tab, and now we're a little bit closer, I guess. It's not super close still, but it's okay. And I think that's us, right? And we're gonna work on the UI so it's easy. Let's just, for fun, yeah, I think 100 meters is enough. But anyway, it's not really relevant right now. We're gonna make this move around now, and we want to make it move around by, you know, moving the cursor, you know, back and forth, right? Yeah. This was way longer than I did one of these codes, so I'm just gonna wing it and see what I can come up with. It's not a hard problem, it's just I don't really know how to structure it. So we wanna, the mouse, when we come close to the edge, should like starts to go that way, and then we come really close to the edge, go faster. Basic RTS camera movement. So we need the mouse position, and we need some sort of a boundary definition of, and I guess we can use, we don't need to take the screen ratio, or maybe we should do a percentage. So a percentage of the screen edge should be detecting as a movement in that direction. So the way I would do this is, first of all, we need the absolute mouse position. That's not a big deal. It's just something like this. Mouse position. And then we do Unity engine. Remember, we don't have the Unity engine library, whatever, namespace in right now, so we need to explicitly get it. So we have mouse position, and then we should sort of, because I don't know, I've never thought about this. My screen is lagging like crazy. Let me just see if there's something specific. No. Oh well, never mind. So I never thought about this, but I don't know if the edges in a normal RTS is like relative to your resolution or relative to or an absolute pixel amount. It sounds like it should be relative, because if you have a smaller screen, you don't want to have huge border, and if you have a larger screen, you don't want to have a tiny borders to move them. It should be sort of the same. So let's push in some value, public float RTS camera RTS frame RTS camera. Oh, I've misspelled that one over there. RTS camera frame width. It's going really weird with my keyboard today. With that, there we go. Let's just fix this as well. Camera. That should be enough. So frame width. So that's basically the size relative to your whole window size. So we can do something like this, where we put in three different variables really. Viewport Unity engine dot screen dot port. I don't really know if there's a. Oh, isn't it like this? Port. No. Let's just use screen. Width height. With float 2 with height. Right. So now we have the actual data. We don't need to pull in screen or input inside. We have the data that we should be able to deduce everything else from. So let's try to do that. So let's normalize the mouse position by X and Y. So we have from 0 to 1 instead of from 0 to whatever screen resolution we're using. So variable normalized mouse X. I usually use the word norm for everything that is normalized between 1 and 0, or 0 and 1 maybe, just so you know. And we have we should have position X times X. So this will, for those who doesn't know how to normalize something, I'm not blaming you. I don't know really how to explain it, why that works, but it just makes it into from 0 to your frame resolution to 0 to 1 instead. Interesting when I think about it. It's hard to explain normalization, or at least the math, not why it works, because it's so you learn it so easy, I guess. Learn it so early, I guess. So now it's from 0 to 1 and 0 to 1. So when you're all the way up or all the way to the right, or maybe the other way around, but when you're on the edges, it will either be 0 or 1 in X and Y. So if we do like this, so if we we first handle X, right? We can make one of these in turn. If normalized mouse position X is less than, and now we need a state that we put in before, state dot RTS. Oh, we didn't we didn't shuffle it forward. So this was, you know, the thing we're gonna put in the editor, and now we need to shuffle it forward into the dots component, right? I just forgot that set. There we go, and now we should have that one. So if normalized x is less than that frame width, and that frame width is going to be between 0 and 1. So if we want the 10% of the side of the frame to be the one that triggers the movement, then this is going to be 0.1, you know, 10%. So if it's less than that, then we should like calculate how much it is in. So that would be variable normalized in frame, something like that. Normalize my mouse position inside a frame. We don't really already inside the left slither of the frame. And we should do something like this, right? So now we're normalized inside of that space, and when we're straight on to the side, we're 0. And when we are just on the edge of the frame, so we're inside of the game, but we're just beside the frame, that's going to be 1 right now. So if we flip that around, we have a value that goes from 0 when you're just along the edge, and then all the way to 1 when you're all the way out on the edge of your monitor. And we can then take that 1 and multiply that by how much we want to move. So it will go from 0 to 1, 0 speed to full speed. And let's do something like this. This sounds like a good idea. Variable move. You can just name it move speed. Move. Well, it's going to conflict with this one, I guess. Or RTS move. It doesn't conflict if you have two variable names the same in outside and inside of a for each. I don't think it actually conflicts in C# in the compiler in Visual Studio, but Unity compiler is gonna complain because they do some transformation of this code in the end, so then it will conflict. RTS move new float 2. And then we do something like this. X is equals to this one. So we could obviously just move that right down, but it's a little bit easier to understand what's going on here. And then if we do the other way, else if mouse X is above, and now we want to detect the other side, and that is basically going to be 1 minus this. I don't know how to explain that. Like I said, it's just intuition from my side, but we're gonna go all the way to the other side of the screen, and then we're gonna subtract out just the frame width that we want. And this one is actually, oh right, I forgot, pause a minute. This one up in here, I remember I said like this gonna go from 1 to 0, and then we need to flip it to 0 to 1. I forgot to do that, so let's do it like this. So when we are straight at the edge of your monitor, that would mean 0 in this value, and then we take 1 minus 0, and we will end up with a 1 here. So full speed ahead to the left. But in this case, we don't need to do that because the whole thing is just reversed because we're on the other side of the screen. That should actually do something. Let's pull in RTS camera speed. RTS camera speed, and then we do like this. And then we're gonna, first of all, we're gonna wait. Skalzam, one of the people in the chat, pointed to me out when I started writing this code that I need to normalize my move. So when you know WSD to move, I need to normalize that before, otherwise you will go diagonally faster, just like in the old Nintendo 64 GoldenEye. I think that was a big hack. The thing is though, in RTS camera mode, I don't think that really matters. If you move diagonally, you're just moving your camera. It's not like you're traversing the environment with your character faster and cheating. Just moving your camera fast in an RTS game, I don't think that's a cheat. So we don't need to normalize this direction if we're moving in both Y and Z, or Z in X and Z in the future. So let's get going here. RTS move. We can actually go for the flow 3 here, because we are just gonna move the camera around with it. And now we need to do it with the delta time, right? Delta time, because we don't want to move the camera faster than just because you have a faster computer, obviously. So in a system base, one of these, or one of the, I think actually component base, you have a time somewhere there, time data. So you can access time wherever you want to access time. So I'm just taking time, delta time, and I need to pull it out into a local variable, because you need to sort of capture the value. And like I said, this is the value. I'm not going to change it. It doesn't have anything to do with something else. It's just this value straight up, and we're putting it into the for loop. If you were to use the delta time inside, then you would have access. You would access the actual like time data that's not in the loop from the beginning, sort of. It's the thing with memory access. It's very important, and you won't be able to use this inside of here. It will give you an error when you play, because they want you to declare a local variable first and then push it into the for each loop. So let's take the camera position and do something like this, and the order of everything here might be a little bit different. Maybe it should be a little bit different, but I think it's going to work just fine. And now we need the state dot camera speed. So now we take this, and now it's only moving left and right, and we're moving it accordingly, the camera position accordingly. That's it, with speed, and also of course delta time. So we get a time-based movement. So yeah, I think that probably works pretty alright. 100, we renamed that, that's why we need to reset it. Frame width, let's say we want 0.05, so 5% of the screen, and then just say 1 in speed. I don't really know how 10. I think it's going to be really slow otherwise. I'm not sure if this is going to work, because not that I just first try feels a little bit too good to be true in this case. So let's move up, tab, and well, almost. You see something happens, right? But what we're doing is this value is not pulled through, because right. So what we need to do is move this. We need to raycast and find everything after we do this, and we need to set the RTS in the ground position, because we're really moving the ground position, right? Imagine like the camera is up, and we're just moving this, and the camera should move with it. That's basically it, because we're gonna raycast down, reverse it, and then find a point in sky where it's straight above the ground position. So we just need to move the ground position, and it should be working quite alright. So this works like it should be. Tab, and well, I mean almost. So this one should be the other way around, and that makes total sense. So first of all, we need to negate it, like I said. So we turn basically 0 to 1 up on its head, so 1 to 0 instead, and then we need to take that value negative, because we need to move in the other way. Unless I completely flip this on its head once more. Well, it works. Oh, it's just because I have shared screen. That's it. A shared screen, I don't know. Split. I didn't know Unity did that actually. I thought they gave you the right. So here we have that, and here we have. Oh, wow! It takes my second screen into account. That's I did not see that coming. I can tell you that much. Why does it do that? That's strange. That's really strange. Oh, but you see, it's an RTS camera. You know, not a big deal. It works, but we should probably pull in something else than screen width. Let's do like this. Let's take Unity viewport size. I just don't remember where it's at. Camera pixel width. That might be it. Annoying if it's inside of the camera. Yeah, it probably is. Camera pixel width. Camera by default takes the entire thing, but you can be changed on and on. Yeah. I think we can look here as well. Yeah, it's the pixel rect or something like that. So we need to pull out that value, and we can do something like this actually. Private, and I'm going to explain why in a few seconds. Camera viewport size. So remember I said we only want to do without burst when we actually accessing the camera. So we don't want to do this without burst and access the camera first to access that view size of the camera and then pull it into our optimized code and then out again. It's annoying, and this value is only going to change if you change the resolution of the game or change the scaling of your viewport in Unity. So it's not a big deal to just save it like this. Rect. Where the screen on the camera renders normal coordinate. I don't know if that's actually the right one still. With pixel width. I think this should be it actually. But Shall Sam, maybe you can use camera screen point to viewport point, since this is outside DOTS code anyway. Well, it's not outside DOTS code. That's the thing. Good idea actually. But I think it's just a matter of finding the pixel, the right value here, and I don't think it's actually. It probably is this, straight up. So we set this every frame, right? We don't need to do it, but if we change the resolution of something, then we're gonna need to do it, and then we use it the next frame. Put it in there. You know what? I'm gonna do like this. I'm gonna take and log both of them right here. So if we do something like this, Unity engine dot debug dot log, and then we do screen dot width. We just compare the width of both of these guys once, just to see what we're dealing with, and then we can do something like this. This might annoy people. Oh, we have gotten this one in again. We don't want that. Sorry for messing around a bit here. Can find the camera Unity engine. This is where it gets a little bit annoying to work without the Unity namespace, but find objects of type camera. So this is just we find the camera. That's it, and we just want to take a look at its pixel width. Yeah. Like I said, it's a good point with turning the mouse into normalized screen coordinates. And I mean, we should maybe do that outside, but I don't know. I like to keep the code in everything that I can inside of the dots for each loops, because that just makes it faster. It's just a good practice. But the point that Skalzam is making is that you could take this and just make it normalized before you pull it in. But I don't have the access to my camera right here. I could have the access. I could just save this reference, right? But I'm gonna try this and see what happens, and take a look at the difference, because that's really what I'm curious about actually. With height, so we're putting the viewports, that should be this size and not anything else, but we'll see. We'll see. No, both of them are really high. That's very strange. I'm gonna just see by just forcing this to be a specific full HD, whatever. So that's okay. That is the actual. Okay, I made something else that's wrong, I guess, because our second crash shot. No, not really. It's just a little. It's the beta. It's what it is. I'm okay. Yeah. Something here, right here, is weird, because this should be 0 when it's straight. We're gonna print this out actually and see what happens. So let's just steal one of these, because this is long, takes long to write, and we can do this and this, and then say that, go over to our main scene, and damn it, I'm just tabbing around here and making sure I have everything saved. That's really the only thing I do. Now we're all again pulling in a debug log right into a run that is bursted, which will give us 2 errors. So just take that into account. And I have not reset my layout because we crashed. So I'm gonna do that now. Better default. There we go. And game. So that's the thing that I was talking about. And now if we do like this, null reference. That's weird. Object set not set to next instance. What? Oh, I guess this probably without burst. When the system captures this thing in burst, it probably just everything falls apart again when the compiler realizes that we can't burst it. If it's not that, I'm not sure. We'll see what happens. It's not that. Why is that doing like that? I'm really confused. Object broad face play controller 224. 224. That's that one. I'm just gonna make this thing to make sure that it is actually this non-burst thing. That's weird. I haven't encountered that issue before. And it crashed again. Does the debugger work with DOTS code? What do you... Oh, you mean, yeah, stepping through. Good question. So this is tricky. Without burst, it generally works like it should. I use it all the time to burst to look at values, and I just put in the the without burst if I need to look at it and do whatever like this. It's not a big deal. But with burst, I think it will technically stop, but then it will be like, oh, I don't know what's going on. It's like if you jump through C++ code in release mode. It's just the code you're looking at is not what it's executing. It's just jumping around in like an optimized way, and it's really confusing to look at. So in burst, it doesn't work. Without it, it does work, but you can't change anything. You can look at values. Some type of values is really takes some time for the system to load in for some reason. So you can like hold over an array, and it's like 20 objects, and it thinks for like 2-3 seconds before it even shows the inside of it. So that's annoying, but it works to debug in DOTS, and we can do that actually. That funny you say this, and I'm just gonna make sure that this not that we have the collision system on the wraps so it doesn't fail again. That would be annoying to have something randomly show up in the middle that I don't have an idea where it comes from. Okay, so I've written something that makes this crash. That's very interesting. What have I done? That's the wrong project. Sorry. I am very confused to what is going on here. Why would this crash? Sorry if people are just waiting to get to the next stage. You could see at least the movement, the RTS movement sort of had a working situation. I'm gonna do like this now, just so we can be a little bit more thoughtful of our investigation here. So there's a button here, open editor log, and I can do, let's see here, we have Notepad++, and we can just, oh, that's the wrong one. We have to go to the Explorer, and we can do previous log. So now we can see what actually crashed. And Sig said, yes, this is like the typical thing that happens in Unity DOTS. And this is, there's no, I'm not trying to apologize for Unity or anything. This is actually the most annoying thing when this happens. And some of it is probably my fault. 190 says, but some of it are obvious Unity that they have not really gotten their code properly working with all of the different sort of weird states you can get into. 190. So okay, so it just says like somewhere inside of this code, which is bursted, so you can't see into it. It's just everything is just failing. That's really annoying. I don't really know what to do if it crashes again. Did the tags saved after the first time it crashed? Wow! Skalsam, you're probably the hero in this story. I'm looking in the wrong scene, by the way. That was a really good idea actually, but it's not that. It's something else. Ground. Let's see here. So the ground is in the right. Collides with everything. Ground. Play rotation. Ground. Rotation. Yeah. I assume this is just because of this piece of code. We're gonna just try to execute this and see if it works without that part. Okay, let's see. It works, but the camera is way weird. It's probably at the 0 point or something. Yeah, it's under us, so we don't offset this properly. So it's the ray cost. and that worked before. So I've encountered this type of problem once or twice before, that is like something just becomes weird. I think I did a mistake when I upgraded to latest version of Unity editor, Unity entities, because I believe that's probably the thing, because this type of problem I haven't had before. There's a few of the calls that I have, a few of the packages which I haven't used. I just like, yeah, let's just use the latest, greatest, so it's as much up to date as it can be, at least, because that's the normal, you know, critique of DOTS, fair critique that is changing all the time. So that's that. I'm gonna do one thing first. I'm gonna wrong one. I'm gonna shut this off and then start it up once, so it just get a proper shutdown for once, because it's crashed like 4 times now. Commit this as a that's a good point. That's a good point, actually. Let's do. I'm just gonna make a copy of this, or maybe do like this. Well. Yeah, that's not gonna be needed. Let's just do like this. So for those who doesn't know, there's a lot of stuff here that you don't need to include. That's basically what you need to include and nothing else. Everything else is auto-generated. So we can do like this. That's better. So let's see here. Let's jump back into Unity and see if we can get anything going here. If it still crashes, I might take a break, and like this stream, I'm gonna develop this game like this whenever I have time. I will try to pick the same time over and over again, but it's just gonna continue, and maybe I will continue tomorrow instead. So tab, and it crashes. Wow, yeah, that is a repo case. Certainly is. I'm gonna actually delete the library. For those who doesn't know what that means, the library is everything that is generated on your computer, and it's like a lot of stuff is generated on platform specific, like, so it works on your platform. So when something crashes really hard like this does, you can probably, at least in old Unity, you can probably just delete the library folder and it will regenerate everything. You can see right now it's resolving packages, which means it's just like loading in all the package dependencies that was previously cached inside of libraries. And it all comes crashing down. Miss Yeti. Yes, yes. It all comes crashing. I'm gonna be right back. I'm gonna bring some more water. Eat some ice. I think it's fine. My throat is actually taking more damage than I thought, but it will be alright. I'm gonna I'm gonna look at the SpaceX launch later, which is in 2 hours, I think. No, 1 hour. Oh, yeah. So in either case, this, and I can talk more and answer questions if somebody have anything, and then we can go through a little bit of some things that I haven't gotten to on purpose yet. While we wait for when I'm inevitably gonna shut this down. I don't know if I'm gonna start it up later today. Probably not, because I want to give everybody the chance to catch up. By planning a specific time when I start. So yeah, we'll see. But anyway, so this code, this part here, did not turn into 0. We wanted this to be 0 when we were straight down to the left of the screen, and then we flip it around and make it 1 instead. 1 minus 0 is 1, and then we make it -1, and then we use that to turn to the left, but we did not get full speed turning to the left. So for some reason this was not normalized properly, and I mean I need to clamp this to between 1 and 0 and all of that stuff. That'll probably be a good idea to do next either way, but it should work better than it did. I just missed something. This is interesting. You see this new thing in Unity 2021. They have a little, this is how long we've been waiting, and I mean it crashes, so screw that, but this is nice. This loading screen comes up all the time. I've been working in it for 3 or 4 weeks now, and this loading screen comes up all the time when it's freezing, and it's just like, okay, it's doing something nice. I know why my Unity is stuck. It's doing something, and that's so refreshing. I don't know how many times I waited for like 30 seconds for something to happen, and nobody knows what's it doing. So energy, give me all of it. Maybe it will work. Okay, it was a little bit more. There we go. Scenes, main scene, loading it in, and it's building shaders. Like it needs to rebuild all of it because there was a lot of stuff in the library, like a gigabyte actually. 77. I don't know what these arrows are. I just ignore most of the stuff coming out of the visual effects stuff because I haven't really used visual effects yet. Yes. Yeah, good idea. All right, let's see. Better defaults. I'm actually nervous about this. This is so annoying. So we are just pushing in the normal things. Nothing fancy here. Ground. Can apply this just for fun. And we can go into this one. And here we have the normal run, which will pick up this, go from start to end with the height of 100, and should find it. But whew, it's almost scary. So this works like it should. And when we flip it around, it's gonna fucking crash. Sorry for swearing, I'm just really annoyed. Yeah, it's just, bam, there it goes. Why is this doing that? I'm gonna, okay, the troubleshooter I am, I guess you're not going to be a programmer unless you want to deal with this stuff. I mean, it could most likely be. Maybe I'm like dividing by zero somewhere. Maybe that's the case, and it's because stuff is in bursts. It's like sort of just, it doesn't have much of a safety net anywhere. So a lot of the normal stuff that just like, oh, you have a divide by zero, fix it. Not necessarily divide by zero, but some stuff just crashes really hard when it comes to burst. And I think that's something they're working on to make so you can have like the learning legs on and then let it go. And I have the learning legs on. It's the enable safety checks right here, but maybe this doesn't catch that. So I'm gonna do like this. I'm gonna attach the unit. I'm gonna see if I can see anything, and I need to have without burst for that. And now it's gonna ask me to switch to debug mode. So we've actually run this in C# release mode so far. And it takes a few seconds to make it recompile everything into dev mode. But it's really nice because damn, so much better performance in the editor when you're running in release. It's like night and day actually. Our own project, which is quite big at this point, it's like it's running, barely running at all if we do it in debug with all of the bells and whistles of the unit editor. And when we do it in release in unit editor or outside, it just, I have like more than 120 frames easily. So that should be it. We should hook up that when we press that one. I'm just gonna So now it takes a little bit longer to load it because it's hooking up the debugger and everything. So let's see if we should have a filled in. Yeah, this have found a symbol at least, so it's not. It's probably gonna find it. Yes, there we go. So delta time, whatever, RTS, ground speed. That is possible. That is possible. That is possible. So. Oh, we have an infinity. Infinity F. Where does that come from? Yeah, it was a divide by zero somewhere. Yes, I actually suck. Because this one has not... Oh! Yes, that makes total sense. So... I'm gonna... This is funny. So the reason why everything like this... It wasn't like me doing something that... Or dots or anything like that. Totally breaking. So no disrespect to dots. All disrespect... All anti-credit to me. The reason why it didn't work is because I wanted this viewport size, which is, you know, pixel width and pixel height from the camera. But the problem is that this is only set when we go into overview mode and after we come through here. So this viewport size is not going to be set until we go into viewport mode. And we need the value before that, because we execute this before. So that's the reason. What we should do is paste it here on create, like that. And that's the nice thing about this kind of about dots. You can move around these systems wherever you want them. It's not a big deal, and they will just hook up like normal. So this should set this, and that's it. And we don't need to actually do like that. We just need the viewport, and we can do this. And I know I'm pulling it out just like a few lines over here, but I don't want that. I don't want to use that thing. That's not how we are gonna set this up. So now we're gonna go on create. We're gonna find our gameplay camera, only gameplay camera, that's the only thing we need, play camera, and then we're gonna pull out the view thing, and let's do like this just to be sure. If 0 or equals to 0, and so if any one of them are close to 0, we're gonna just print out 0, because I've made some other problem. And we're gonna set it to something so it actually makes sense, so we don't get a crash, because that's just really goddamn annoying to have to restart stuff. So that should sort of cover our bases. But this was the original problem, right? We needed this value. So yeah, debugging without burst works well. Nice. Ah, it's 0. Now we got it. We got the 0. So obviously this doesn't, the viewport size float doesn't work. I'm looking at the wrong place. So we don't. That's interesting. I wonder if we are not getting anything of this, because maybe we, by the time this is created, you know what? Let's just do it like this. This is wasting time on stuff that nobody cares about. This is just initialization order stuff, and people should do it however they feel like they want to do it, right? So this should work. The only thing that's gonna happen right now is the first frame afterwards we switch to it. It's gonna take a frame for it to get the right pixel sizes everywhere, the right viewport size, and hopefully it won't really matter. And we can actually do it either a little bit easier than that to make it a bit cleaner. So we can do it. I'm gonna copy this part out actually and do like this. If this thing is like that, we just return. Nothing will happen. We just will not be able to move it. That's it. And that one. And you can return straight in one of these functions. And it's not going to return like you used to with the, returning out of the function altogether. Well, it is returning out of the function altogether, but this function is just one function specifically for one entity. So when this is the equivalent of doing continue in a normal for loop, you're just going to the next. In this case, we only have one player, so it doesn't matter. We're just going to jump out of the whole thing. But if we had a few of them, then this return would just jump to the next. That's worth a little bit of whiskey. Oh, it feels so good not getting stuck on a stupid thing like that. So, and this works, and this almost works. But now we can debug this. Now it's pretty easy to debug. So if we put the mouse right here, really close, and then we tab, and then we do this. Oh, I need to actually have attached. Oh, wait a minute, we can just do like this. So we're just gonna check out the value, see whatever happened. And I'm gonna it's so annoying because I can't really get to that point unless I something happened behind my back here when I wasn't looking. I'm gonna put it on the other screen. Just a moment. It's tricky to debug stuff when your mouse depends on it. So right there, and then I tab over to my project and I put the breakpoint, and we're there. So right now we're on the right on the edge of the screen, and we should get this should return 0 because mouse position is basically 0 and width is that, and well, I mean, I guess we're close to 0, but we're not really that close to 0. You know what? I'm gonna print out this stuff. Now when we have the stuff under control, we can actually take a look at what's happening here. There's gonna be a bunch of stuff showing up on the screen, so we better do something like if input unity engine dot input dot get key down, get key down, and then like K or something. I don't know, it doesn't matter. The reason why I can do this inside of straight in here is because I have this without burst width. This would completely fail if I don't have the burst K with a big K. So now we can just like sample the actual data by pressing K once, and that's pretty important in this case because you're in lambda. I don't know what that was an answer to. You mind writing blah 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 because you are in lambda? I'm sure you're correct, but I'm not sure what you're pointing to. There's a bunch of stuff which is... Oh, you mean the return? Yeah. That's because it's lambda. Yeah. But I'm... Yeah, exactly. The return statement. But I didn't say lambda because some people like doesn't really know what that means, or they know what that means, but maybe they don't really understand what it means in this context. Like it's an actual function which you go into in this case. Well, lambda is actually just a term described when we're doing what we are looking at. The real behind is not a lambda. It's code generated to something else because lambda is garbage creating. I can go through that when we try this. It's actually pretty interesting distinction. So right now here, if we press K, we have we don't have any spaces, but you can see there normalized mouse position is almost 1. That means that this mouse position, you can see, I don't know if you can see this very well, but the mouse position is almost 1800 and our viewport is a little bit over 1800 units wide, which means that our resulting normalized vector, normalized value is going to be almost all the way to the edge, and that's why we get full speed. But if we clear this out and we pull this one here and press K, there we go. Okay, so mouse position is normalized, it's pretty low, but the mouse position is actually, well, it's 28. 28 is kind of far actually. Oh, 0 is over there, so this is 0. So something else is going on here. This mouse position X let me have a look at this as well. We should approach very much 0 when we get close to this, to the 0 value. I wonder if there's a problem with it being non-float. No, everything was float, so that shouldn't be an issue. So lambda, when you create a lambda, when you have an action or something that you put into to a function, like on click or something like that in traditional Unity, that if you do that each frame, like we do here, we create this thing here. This is the lambda, right? There we go. If we do that each frame, that will create dynamic managed data every time it's run like this, and that's fine in C#. It's not a big deal, but it will pile up in the garbage collector, and then eventually the garbage collector will have to trigger and to clean up all the mess that's not used, and that cleanup that introduces hiccups and lags or whatever you want to call it. So this is not actually lambda in the end. It works like a lambda, but it's compiled to something else. I don't really know how it looks, but I know it's not the garbage creating lambda in the end, because that's really not, that's like completely opposite of the idea of dots. Now let's go here and let's press K again. So now we have this. It's really low. There must be something else that I missed here. It's so low that this should work. This should very much work. Normalized mouse index frame. Not normalized. Yeah, this one is the one and it was basically 0. So we have this. And for some reason, when we're done with this, I think I'm gonna go and watch SpaceX stuff. But if we can get this to work, I would be very much happy. RTL. Yeah, it should very much be working. And we're gonna put another one here just so we can see the difference. It's loading. Tab. I'm curious to what this looks like first, actually. So right now we have. Oh, I see. That is because. No. Wait a minute. Times are width. Camera frame width. That should be the correct one. This should have sort of the same size. That should be scaled up a bunch when it goes through this function, because this one is below 0. So dividing by below 0 will, make it be bigger instead of smaller. So that's very, very strange. I don't really know what I've done wrong. Yeah. We'll see here if I can figure it out quickly. K, and we now have so this one is basically all the way to the right. We get a 1 because we are all the way to the right of the screen, and then when we divide by the 0.05, which means 5% of the screen is supposed to be the frame, then we get 20, which seems reasonable. But oh, I understand. I did it in the wrong order. So the scaling, the thing that makes this go from 0 to 1, it's most likely in the wrong order. So we need to negate this stuff first, I think. Exactly. We should do. This is most likely what we need to do, because the scaling depends on the actual value, which is not what we want. That's something you need to think about to really realize. It's spinning in 120 in my head right now. So, but it's I think this is correct, and I can give a better explanation if it's correct. Yeah, yes, that's correct. So that works fine. Right? That's sort of a good speed as well, actually. I think we have some scaling issue. It's not really working like it should be. I think I'm actually the other way around would be right, but increasing the speed. I was very much curious to why they were difference in the end. But my throat is getting a little bit weird, and SpaceX is gonna fly in like I don't know, 40 minutes, and I'm a huge space nerd, so I'm gonna leave you guys here, and I will post ending. Yes, May, your name is tricky. Messieti. Messieti. Yes, we're ending. I will return to this. I will call this whole game on stream. So follow me on. Look in the description. Follow me on social media. I will tweet it out or anything. I'm not trying to like, oh, follow me. I'm a big influencer or I'm wanna be. That's not the case. I just want to show off some cool dot stuff. That's it. So if you feel like you have an interest in looking, seeing this through, just hold and look out for where I post stuff, and you will see it. I'm not a huge social media guy otherwise. So yeah. Ending. Thanks for watching, everybody. I'm gonna see. Thanks for the show. It was really informative. Thank you. It's very hard to know what level you're supposed to be at and everything like that. It's really tricky. I am constantly trying to think about what actually matters for people to hear in this case. And when we get bogged down and stuff that obviously it's not really dots related, just general game logic, it's annoying to me, but still it's like I want to show you the whole thing, even if it's not really dots, because it will build a whole complete model of how to work with it. So yeah, thanks for that. I will certainly, yeah, we'll see. Maybe tomorrow. Maybe my girlfriend will want me for herself tomorrow, but maybe tomorrow otherwise. Have a nice day, and see you next time.